Things is a giant network of interconnected devices. Now, these devices are capable of making decisions without any human intervention. Hi all, I welcome you to this full course session on the Internet of Things, and what follows is a series of fundamental concepts on the Internet of Things which will help you get started with IoT. But before we begin, let's look at our agenda for today. So we're going to start out with introducing you to the concept of IoT. We are going to discuss why we need IoT, what is IoT, a few benefits of IoT, followed by a few features, and finally the very important 5-layer architecture of IoT. Then we're going to discuss Raspberry Pi. In this section, we are going to talk about why do you need Raspberry Pi, what is Raspberry Pi, a few hardware specifications, and the installation of Raspberry Pi. Also, in this module, we have a few demos, including the Raspberry Pi, a few Sense hats, and a Raspberry Pi camera module. Next, we are going to discuss the top 7 projects in IoT. In this section, we are going to talk about the best projects that we found in IoT. Next, we are going to talk about IoT devices. Here, we're going to talk about various devices which came into inception after the concept of IoT was introduced. Then we're going to talk about IoT applications. In this section, we are going to discuss practical applications of IoT in various domains such as healthcare, security, traffic, governance, so on and so forth. And finally, we are going to discuss all things career in IoT. We are going to talk about the job market, the opportunity, the salary in different geographies and experience, so on and so forth. With that, we come to the end of our agenda. Also, kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. So without much ado, let's get started.
What is Internet of Things? Now, to help you understand what is Internet of Things, let's look at an example of our mobile phones first. Okay, our mobile phones has GPS tracking. It also has mobile gyroscope. You have adaptive brightness which gets adjusted based on the light falling on it. You have voice recognition, and you also have face detection which identifies who is the user. Now again, iPhone X is coming with face detection. So again, these are a lot of features that are coming pre-built on the mobile as such. And most of these have a common interaction between them, because let's say one application can use all of these features. I can also have these features in itself being interacting with each other. Let's say based on a GPS location, my brightness could be adjusted, or based on the direction my phone is being held, the brightness in itself can also be adjusted as well. So there are a lot of features, but when they interact with each other, these features come together to bring in a better system than anything that they can provide individually as such. That's what Internet of Things is. It basically is a platform wherein we can connect everyday things which are embedded with either electronics, software or sensors to the internet, and this in turn enables us to collect as well as exchange between these things. Now, when I say things, it can be anything and everything. Let's say I have an internet platform wherein I can connect these things. If I take the example of my house, I can connect my lock, I can connect my AC, I can connect my lights, and all this can be managed on the same platform. Now, since I have a platform itself, I can also connect my car to this. I can keep a track of my fuel meter, I can keep a track of my speed limit, I can also keep track of the location of the car as well. Now, if there's a collective platform where all of these are connected, wouldn't it be great? Because I would love to have the AC on and set a cool temperature at my home by the time I reach back from office. If I have a platform that knows my preference and that keeps track of where I am and where I'm going to, then it can also identify that I'm going from work back to home, and my preference suggests that it would be best if there was an AC temperature of about 22 or 23 degrees centigrade. And this is something that is definitely possible through Internet of Things. Now this is just one of the examples. Now let's say tomorrow you come back home. It would be great if I wouldn't even need a key to unlock my door. My home system should be aware that I have come home and it should unlock all the doors that are needed. And now this can be done if my mobile and my home devices are connected onto the same platform. Based on the location of my mobile, it can identify that I am at my home. So it will automatically unlock the door and let me come in as well. These are some of the real world implications of Internet of Things. These are something that are already happening. But going forward, what we need to understand is that when I have a specific component with me which can do a lot individually, wouldn't it be great if I can collaborate this component with my system of different components and build a better system? This is what Internet of Things is helping us do. Okay, you provide a platform through which all these things are connected through the internet. So internet becomes the medium through which you're connecting all these components or things to a platform. Moving forward, let's try to understand why do we need Internet of Things. Now to help you understand why, let's look at an example. There's a patient at home. Okay, he's on constant life support wherein his status is being checked to a health monitoring system present on the cloud. Let's say at a point there is certain issue with respect to his health. Let's say there's some irregularity with his heartbeat or his blood pressure is low, there's some fluid being developed or so forth. Now what happens is, since the system on the cloud is connected to a hospital as well, this information would get passed on to the hospital as well. Therein what would happen is that they would get the complete details with respect to the patient and the important information with respect to the current situation of the patient as well. We made it aware with respect to what issue exactly is the patient facing, as well as enable them to dispatch an ambulance immediately to bring the patient back to the hospital as well. Now, meanwhile, once the patient has been picked up and brought back to the hospital, there could be prescriptions, there could be medicine, there could also be an operating theater made ready in case of an emergency situation as well. There'd be doctors on standby who have the complete history of the patient, who have the complete details of the present condition of the patient as well. So this in turn brings in a lot of transparency and reduces a lot of effort and time involved with respect to this. Same thing, let's take in today's scenario. There has to be someone monitoring this patient's health. And if there's a fluctuation, they need to call the hospital, they need to call request for an ambulance. And meanwhile, once the ambulance is here, they take the patient and they're back into the hospital. Then again, there needs to be a lot of checkups that need to be done because the doctors are not fully aware. Again, there is a lot of tests that need to be run, and this in turn leads a lot of delay as well in certain emergency cases as such. Now, if a system can do this, then this is exactly where our future lies in and what we have to definitely move forward to. Now, Internet of Things basically is expanding the interdependence of humans to interact, contribute, and collaborate with things around us. Now, what do I mean by interdependence of humans? How we depend on each other. Like how I'm explaining this concept to you. If you're not clear, you would reach back to me, you would request me for help. Okay, this becomes an interdependence between us. When I'm giving you knowledge, when you're not clear, you're coming back to me and you're helping. Similarly, tomorrow, if there's something that you can do for me, I would reach out to you. So we all are interdependent on each other for something or the other. If we can expand this interdependence to interact, collaborate, and contribute with respect to the different things around us, then we would be building a proper Internet of Things environment. This would be a much more safer, secure, effortless, and time-saving environment in existence. Moving forward, let's talk about the various benefits of Internet of Things. Now, the first thing that would be as a benefit of having an Internet of Things platform would that it would efficiently utilize the resources that are available. If I have a smart system which can interact with everything, if it has enough computational power, if it has enough understanding of how things work between each other, I'm quite sure the usage of the resources available will be more efficient as well. This resource could be in terms of monetary, it could be in terms of natural resource, it could also be an input taken up by the thing as an input and so forth. Okay, so all this can be more efficient if I have a platform which is more smarter and interconnected as well. Apart from this, it minimizes the human effort involved. If my system is smart enough to interact, if it is smart enough to do things that I don't need to get involved with, then my interaction is always going to be minimal. This is the same with everyone. And that's one of the major reasons why Internet of Things has become popular today. And the concept of smart home is always growing as well in the same perspective. Because if the system in itself is able to do most of my work at home, then I don't need to put in much effort. I can relax at home without having to worry about anything. Okay, the next benefit would be it saves time. If it reduces my human effort, definitely it is going to save my time. Okay, apart from that, if the resources are utilized more efficiently, then again it is going to save a lot more time as well. All in all, any benefit of Internet of Things will in turn help you save a lot of time as well. Okay, so time is one of the major factor that can be saved on an Internet of Things platform. Now, if I have an artificial intelligence platform through which all of this is managed and maintained, then the personalization and the human touch also comes into the picture. Now, today most of us have had a level of interaction with an artificial intelligence or a virtual intelligence as well. This could be a personal assistant like Siri, or it could be an assistance application like Google Assist. Now, if I have a system where all these components and things are interconnected, then in turn all the security present on each of these things is going to get multiplied and it's going to build a much more secure system. Apart from that, the level of security that you would be integrating to the platform in itself is going to be quite huge. So the overall security with respect to everything is going to increase multiple times as well. Now let's look at some of the major features of Internet of Things. Now, any technology that is available today has not reached its 100% capabilities, and it always has that gap to grow. Internet of Things is one of the major technologies in the world today that can help any other technology reach its true and complete potential as well. Now, there are mainly three aspects to Internet of Things as to how it works. First is the connect aspect. Here, basically what you need to work on is you need to ensure that there's a connectivity between all the things around you, all the necessary things to the Internet of Things platform. Okay, then comes analyze. Now I have my things around me. They each are going to generate some amount of data. Now this data needs to be collected and it needs to be analyzed to build a business intelligence solution. If I have a good insight from the data that is gathered from all of this, then definitely I can call my system as a smart system. Finally, what happens is in order to improvise and improve your system, you need to integrate it with various models to improve the user's experience as well. Let's say there's a personalization module that is there, or let's say there's going to be an aspect wherein I can directly connect to my providers. Now this provider could be Amazon, it could be Flipkart, it could also be my retail store that is next to me. Let's say I'm out of milk, the retail store would get a notification and he would send milk right away. And the same thing can be done. Let's say my coffee machine requires special beans and this beans is almost complete. Then what my system could do is it could go online to Amazon and purchase these beans for me as well. So there are a lot of things that I can do when I integrate this with respect to various models and improve the overall experience to a single user or a group of users or the world itself as such. Okay, now let's talk about each one of them one by one. Let's start with Connect. Now, the first stage of Connect is device virtualization, because what you need to first do is that you need to standardize the integration of the device to the enterprise platform which is present on the cloud. Okay, now it could be present on a cloud, it could be present on a server, but again, it's all going to be connected through the internet. So what I need to do is that I need to ensure that certain level of standard is present on the device so that it can go on and connect to my Internet of Things platform. Now, to help you understand this better, there could be a standard power plug and there could be a power plug which has an inbuilt Wi-Fi support so that it can connect to my lab. Now, to build a smart home system, I need the second power point because there only I would have the access to control it over the internet and my system could integrate with respect to the same. Okay, now if I take the first standard power point, then what would happen is that I need to manually switch it on and switch it off. However, in the second case, I could send a signal to it and this in turn will switch it on and switch it off. So there's supposed to be a level of standardization through which I can integrate all of these devices to my platform. Next comes high-speed messaging. So now what I have done is that I have connected all these devices to my platform. But these devices in turn generate a lot of data and this data is what is going to help us understand better on how we can improve the overall system and help and provide the user with better experience. So for that we need to have high-speed messaging. Okay, this basically means that there needs to be a reliable, secure and a bidirectional communication channel between the devices and the platform. Now the purpose of it being bidirectional is because you need to control each one of them as well. Let's say I want to switch on the AC, then the signal would be going on from the cloud platform to the device. So this is how it works out. Okay, so every communication needs to be reliable, it needs to be secure and it needs to be bidirectional as well. Moving on to the third point of connect, you need to have endpoint management. If I don't have an endpoint management, I have established a way through which all my devices can connect to my platform. I've also ensured that the data is going to be sent from the device to the cloud, and the cloud can send back to the device as well through a secure channel. But if I don't actually identify from which device which data is coming and how this data has to be processed, then it becomes a failure of the system. This is where endpoint management comes into picture. Endpoint management basically helps you in managing the device's endpoint identity, the metadata, and the overall life cycle involved with respect to these things as such. Okay, so to put it quite simply, it basically helps you identify from which device which data is coming and what needs to be done with this data as well. Now, coming on to the next feature is analyze, and the first thing that you need to do for analysis is the stream processing. Now, if the data coming from the device is not on a real-time basis, then my system is of no use. There's no use if I tell my system to switch on the AC at my home, and by the time I reach there, if the AC is not even turned on, then it's a failure on my system. Okay, so real-time analysis of the incoming and outgoing data must be done with respect to different aggregations, filtering, correlations, processing, and so forth. Okay, now apart from this, what you need to do is that this is raw data that is being streamed from all the things. You need to identify which is contextually important information which is going to be taken forward. So once I have the relevant information, then I can even generate composite streams of information which can be taken ahead for future analysis and understanding as well. Now this is what your data enrichment process does. Then you have event store. Now in event store, basically any information that you want can be queried and visualized from the vast amount of data which is present on my cloud platform. Okay, now this in turn can also help me get a better insight and analysis. If I have all the enriched data present on my cloud platform, I have a tool which helps me identify what is needed, helps me analyze this data, helps me visualize it, then definitely it becomes more useful as well. And when I have data coming from different things as such, this in turn can also lead to being a collection of big data. Now, when I talk about big data, it's not just few GB of data, it's going to be terabytes of data because the data generated from the things around us is that vast. And if you're doing it over a period of time, then definitely it is going to grow into a big data domain as well. Now, coming to the third feature of Internet of Things comes enterprise connectivity. So this is what I was basically telling you about. Let's say I have a requirement from my retailer or even an enterprise organization which is present. It could be Amazon, it could be Flipkart, anything as such, any enterprise organization which provides me a service. If I can connect to them through this platform, then definitely my overall process also becomes easier as well. Let's say there's a service provider. Okay, let's say there's a leakage in my plumbing, or let's say there's some issue with respect to my electricity. Then it can contact to the corresponding service provider, it can send them a detail, and correspondingly they would be dispatched. This would in turn reduce my effort of having to check the problem, having to call someone, wait for them to come back. All that gets reduced to minimal required effort as well. Now, how does this communication happen? So for that we have REST API. Okay, once I've integrated my REST API with respect to the cloud application and my Internet of Things, then communication between the enterprise, communication between the platform, and the communication between the things around us can be made more efficient and can be more easy as well. Now, the third aspect is command and control. If I don't have command and control on my platform, then it's of no use. Yes, I build a very great environment, I build something that's quite extraordinary, but if I cannot command it, if I cannot control it as per my requirement, then the system in itself is not useful. If I cannot tell my door in a smart home to unlock when I want it, then it becomes failure on my part. If I cannot control the AC on my smart home, then again it's a failure. So always the major aspect when you integrate with respect to these things, the major thing is that you need to ensure there's a huge control on the system and you're able to command it as per your requirement. Now this command could either be through a voice-based recognition, it could also be a message that you can send through your mobile application and so forth as well.
When we come down to the IoT ecosystem, there's no single consensus, or again, there's no single architectural design that's out there which is agreed universally, because each company, each organization, each user for that matter has different requirements. And when we look down to it, we can break it down to a simple 3-level architecture, wherein we have a perception layer where sensors actually gather the information from the environment around it. Okay, once this is done, I'm going to pass this information to the network layer. The network layer in itself takes up the responsibility of transferring this data from the sensors to the next layer, which is the application layer. Now here the main objective or the responsibility is the application in itself delivers this information to the end user or the end platform for that matter. This architecture can also be expanded to a 5-layer architecture. Now, when I talk about a 5-layer architecture, it's quite similar here itself. The difference mostly comes around with respect to the transport layer, the processing layer, and the business layer mostly here. When we had 3 layers doing the earlier task, we've just broken this down so that we have an easier operation or a smoother system for that matter. Now, again, the perception layer remains same when it gathers the information from the sensors, but the transport layer actually transports the data between the sensor to the processing center. Now, this could be through a wireless system, it could be through Bluetooth, it could be through RFID, 3G, NFC, or any medium that I choose to. Once the information has been transmitted, the processing layer comes into picture, which actually stores the relevant information, analyzes this, and again processes it as per the user's requirement. Now, again, this could employ various databases, cloud computing services, as well as big data processing modules to store this information as well as process it for that matter. Once this is done, I give the information to the application layer, which is actually responsible for delivering various services to the end user for that matter. On top of all of this stands your business layer. Now, any device for that matter, when it is working on a large scale environment, a business layer is usually used here. Now, let's say I'm working in an organization where we're using multiple pumps for different use features in different locations for that matter. A business layer here actually monitors the complete functioning of these pumps. You can also have these in various cars as well. So what I would know here is if a car is going to break down, then I also get an awareness with respect to that individual car, and it also helps me enable or helps me reach out to the closest customer care center so that it can assist the user. Coming down to how I can process it, again, this can be divided into 2 segments. I have my cloud computing based processing, wherein here it's quite simple. Once I have the information, I pass it on to the cloud platform, which then in turn also processes it and also has various applications to deal with this processed information for that matter. Now, again, this is something that I can do on a system which does not require any immediate action and requires a large amount of processing for that segment. But let's say I'm in a system where I need immediate response. In those cases, I can go with my fog computing. Now, again, fog computing is something that represents a layered approach wherein we actually insert monitoring, pre-processing, and storage with the security layer between the physical and the transport layer. Let me just go back a few slides here to help you understand this. Now, if you actually look, my fog mostly comes between these 2 layers, wherein I add 4 new layers for that matter. Now, again, this is used in order to make a system quite smarter or effective with respect to it. Now, between my physical layer and my transport layer, I have a monitoring layer, I have a pre-processing layer, a storage layer, and a security layer. Now, to help you understand this, let's take a real world example out there. Let's say I have a complete traffic system which is built on my Internet of Things. Now, let's say at one point there is an ambulance that has come to a first signal. I detect this, and what I do is that I allow the ambulance to move from this traffic signal by giving it a green light. But what you need to understand is if I'm using a cloud computing, this message has to be passed on to the cloud. This information has to be then processed, and then correspondingly a map has also to be created. At the same time, when I use a fog approach, what happens is that all the pre-processing and the storage happens on the gateway level itself. The information from the sensor goes all the way till the gateway. Therein, it actually pre-processes this, stores the relevant information, and sends this back to the corresponding sensors as well. So let's say if there's an immediate track that I can create to the closest hospital, I would highlight all the traffic signals to be green so that the ambulance can move smoothly as well. Now, security here is very essential because if I implement this, tomorrow anyone can actually try to manipulate this for their requirements as well. Imagine there's a high-speed police chase happening and the culprit uses this in order to move fast from the traffic signal. So this is something that is really essential. Although there is a pro to this, there's also a con, and this is how we try to overcome this issue. Now, talking about each one of these new layers, when I come to the monitoring layer, what it actually does is it monitors the power consumption. It monitors each of these resources as well as their response and the services that are running on these resources. Now this in turn helps me monitor or gives me a complete idea of which are the services or which are the sensors which are working, where are the challenges, what is the power consumption, and how it works with respect to that same. Now once I have information from these sensors, what you need to understand is that usually you work with thousands of sensors in a real world environment. Now I need to understand which are the necessary information. So I'm going to do a level of filtering, I'm going to do a level of processing, and then I'm going to apply a level of analytics to understand what is needed and what is not from these information as well. Now the temporary storage area is something that I use in case I want to store any relevant information. Let's say I'm creating a route today for an ambulance as well, and this is going to be stored in my temporary storage area, but this also needs to be used in future scenarios. So once I'm done with this usage, I can also push it on to the next transport layer, which can send it to any other storage system that is part of my environment. Now as I said, security plays a very important role. Although my fog computing is something that makes my system faster, it should not be easily manipulatable. Now, in a cloud-based system, I have the assurance that it's not really easy to break down the security. It's quite hard, where there are various layers of security which are part of the system. But when I have a fog system, it's essential that this factor or the security which deals with the encryption, which deals with the privacy of the information, the integrity of this information is maintained. Now, there's also a very interesting variation of this which is called an edge computing system, wherein rather than doing all these operations after I have gathered this on the gateway, I can do it on the individual nodes or individual sensors as well with respect to it. So where I have edges, these becomes point for me to perform operations on the data that is being collected. So that's a slight variation of our fog computing system as such. Next, let's talk about the various taxonomy associated with Internet of Things. Now, these are the key concepts or these are the key layers which are present with respect to most architectures that's out there. Now, as I said, this is a generic idea. Each person or each system that's out there requires its own level of customization, requires its own level of approach to solve that problem. But these always remain the fundamental layers which are included in all the architectures out there. First, we have the perception layer, which is usually the layer where we gather the information from the various sensors that's out there, or we use the various sensors which are required as part of our system. Then we have the processing layer, wherein we perform filtration, we summarize the data, we again do a level of analytics on this data before we decide to send this relevant data to the system that's above this. Now, then I have a communication layer. Now, communication layer is very simple, as in here we'll define the protocols and standards as well as the medium through which the information has to be passed from my sensors to my main system as well. Now, middleware is something that's quite essential here. What it does is that it creates an abstraction as well as it makes my system work much more smoother. Now, what you need to understand is that there are various components involved here. Middle layer really helps me integrate the information coming out from each of these sensors or each of these individual systems. Once it's present, then I can pass it on to my application layer, wherein I have various applications which help to improve the overall experience of the user as well as provide much more accuracy and efficiency to the information that's present. Now, coming down, let's talk about each layer one by one. Now, before I talk about the perception layer, what you need to understand is that one of the most important aspects of Internet of Things is context awareness. That is, what you need to understand with respect to the change of environment is very important. And this is extremely impossible without the usage of sensors as such. Now, sensors in themselves are very small in size. They again cost you very little, and at the same time, they consume very little power. Again, there are various constraints with respect to the factors as the battery capacity and the ease of deployment as well, but let's not go into them as such. Now, when I talk about sensors, again, we have various types of sensors as such. One of the easiest example of sensors that can be seen on a daily basis is the sensors which are part of your mobile. You have a location sensor, you have a movement sensor. Camera in itself is actually another sensor. Your microphone, your light sensor, these are all various important aspects of your mobile that we use on a daily basis. Apart from this, neural sensors, medical sensors like the fitness bands that we use, healthcare bands which are used for heart patients, again environmental sensors which check the temperatures around the environment, make you aware of the changes, chemical or biosensors which are very useful on a daily basis as well. Again, infrared sensors are something that's quite common as well. Now, when we talk about RFID, this is something that's really important, or this is something that really gathers a lot of attention with respect to it. RFID stands for radio frequency identification. Now, unlike a traditional barcode, it does not actually require a line of sight of communication between the tag and the reader, and can identify itself from a distance without even a human intervention or a human operation for that matter. RFIDs are technically of two types. You have active and passive. Active tags actually have some amount of power source associated with it, and passive sources do not have anything related to it. And when we talk about the RFID technologies as well, there's near and far. A near RFID reader uses a coil through which we actually pass AC current and generate a magnetic field. Now, when we generate a magnetic field, anything that comes in its vicinity, it registers with respect to it. Now, when I talk about a far RFID, it basically is a dipole antenna in a reader. Now, this again propagates an electromagnetic waves, and tags themselves also have a dipole antenna. Now, again, these are something that's used in various applications that's out there. Now, one key factor which is associated with the perception layer is an actuator. Now, when I talk about an actuator, it actually is a device which can affect a change in the environment by converting any sort of energy into another. Now, this could be a motor which is generating electricity. This could be a windmill which is converting the wind outside to you to a electric form as well. Again, these are just some of the examples that's out there. And actuators themselves play a very essential role in the perception layer. Now, the next layer that we have is the pre-processing layer. But before I really talk about the pre-processing layer, let's actually try to understand the limitations of trying to process everything that we have on the cloud system, which is part of our ecosystem. Now, when I talk about this, one of the key or one of the biggest challenges for me is mobility. Let's say my sensors are on devices which are in constant motion. Then it becomes a really high challenge for me to pass this information continuously to my cloud environment. Again, this could be through the challenge of transport layer. This could also be due to the challenge of power consumption associated with it. When my smart device or when my sensors for that matter are in constant motion or are in constant mobility, then it cannot completely pass all the relevant information onto the cloud. Now, this in turn actually causes a challenge for me to have some latency. This could also lead to a latency with respect to real-time processing of the information that it gets as well. Now, if I'm working on a critical system, then real-time information is something that I highly depend on, and that becomes a challenge as well. Now, if I really want to scale up, if I want to use a lot of devices, then my cloud computing system also needs to scale. But there's always a chance to increase the latency because I'm working with multiple sensors or multiple devices that's out there. Imagine today I have a system which just includes 1,000 sensors. But let's say in a smart home system, there's close to about 10 to 20,000 sensors associated with it. So this is just one small system. Imagine if I'm trying to build a smart city. In that case, there's going to be hundreds of thousands, millions of sensors that's out there. If my cloud computing system cannot process this on a real time, then there's going to be a high challenge with respect to that. Say, and this is exactly where the usage of smart gateways comes into a picture. This layer actually helps me process my data on real time. It also helps me filter the data on based on the priority or the requirement and creates a local copy of whatever is needed or whatever needs to be taken forward. Now, when I come to the pre-processing layer or when I come to the features of fog computing for this matter, there's a very low latency because the information does not have to go to the cloud system wherein the processing needs to be taken up. It always is done on the gateway level itself. This information really is faster, as we've seen in the previous example about the ambulance. Now, I can also use distributed nodes wherein the information does not have to be, or the processing has to be on one single node for that matter. When I'm using distributed nodes, then I can also distribute the effort or the work that is needed as well. When I'm on a mobile environment as well, these smart systems can communicate with the gateways present in its closest proximity. It does not have to connect to just one single gateway. If I'm setting up gateways across multiple points in my city, then it makes it quite faster and more efficient. And this in turn can also lead to a real-time response from the gateway for that matter. Once I have a real-time response, then it is making my system faster. And as in the previous example, rather than just clearing one signal, I can clear an entire path for the ambulance as such. Now, once I have relevant information, those which are necessary or those which are really something that I need to ponder or I need to analyze can be sent to the cloud system as and when as it's needed as such. So this is something that really makes my pre-processing layer important and efficient and effective. Coming to the next layer, which is the most important layer that's out there, which is my communication layer. Now, as your Internet of Things environment actually grows, this is a compromise, or this is a combination of various heterogeneous devices which are connected to the internet. What you need to understand is that these devices in themselves need to pass these informations, and some of the challenges that the communication layer should actually address is with respect to, let's say, first start off with addressing and identifying of each of these informations, wherein I know which device is sending me the information, what is that device, if I want to communicate back to that device as well, how do I do that. Again, when it comes down to the communication in itself, this should also not cost me a huge amount of consumption with respect to power, because if I save up a lot of energy with respect to how the information is gathered, but I waste a lot of energy in transmitting this information, then I don't have a smart system. Again, information itself which comes should use various routing protocols which actually require very low memory and should be very efficient for that matter. If the information itself needs to be bounced around different layers going from different segments of your ecosystem, then it needs to use very less memory. And this itself should be very fast as well as seamless for that matter. Now, when I come down to each of these components for that segment, let's talk about NFC, or the near field communication. Now, NFC is actually a very short range wireless communication technology through which usually mobiles interact with each other over a distance of a few centimeters for that matter. Now, all the type of data can actually be transmitted between two NFC enabled devices in seconds by bringing them close to each other. Now, this in turn is actually based on the RFID concept, and it uses a variation of the magnetic field to communicate data between two NFC enabled devices. Now, if again we go down into slight specifications, NFC usually works on the frequency band of 13.56 megahertz, but again, this is very similar to high frequency RFID. Now, I'm not going to bore you more with respect to the technical details. We'll talk about the next segment, which is your RFID and WSN integration for smart objects. Now, again, many a times what you need to understand is that data from one single sensor is actually not useful for monitoring large areas and complex activities. Now, here what you're going to use is that you're going to use various sensor nodes to interact with each other. Again, this also has to happen wirelessly. Now, the disadvantage of a non-IP technology such as RFID, NFC, or Bluetooth is that its range is very small. So they cannot be used in many applications wherein large area needs to be monitored through many sensor nodes deployed in various locations for that matter. A WSN, or a wireless sensor network, consists of 10 to 1000 sensor nodes connected using a wireless technology. They collect the data about the environment and communicate it to the gateway device and relay the information to the cloud infrastructure over the internet as such. Now, when I come down to the IoT network protocol for that matter, usually what you need to understand is that the IP4 protocols themselves can only be used for communication of close to 20,000 devices. Now, again, the internet protocol used by these devices is something that's quite a challenge as well. Because when you look at it, the predicted amount of devices that's going to be available by 2020 in the Internet of Things domain is close to 40 billion. Imagine 40 billion devices communicating with each other. Now, if I don't have a smart system, or if I don't have an effective low power system, then I cannot communicate, or I cannot gather the information from this. Now, usually a low power IPv6 is used for these network or these communication, which helps you in passing of information from these sensors onto your processing or onto your cloud infrastructure. Now, again, when I come down to the low energy technology, my main challenge with respect to communication is always to ensure that low energy technology is most probably used. In this segment, we have your Bluetooth Low Energy, which is usually referred to as a BLE, and this was actually developed by the Bluetooth Special Interest Group. Now, what you need to understand is that it actually has a shorter range for communication and consumes lower energy as compared to its computing protocol. Now, the BLE protocol stack is actually quite similar to the stack used in classic Bluetooth technology. However, it has two parts. It has a controller and it has a host as well. Now, the physical and the link layer are implemented in the controller, and the controller is typically an SoC, or a system on chip with a radio for communication. Now, the functionality of the upper layers again are included in the host, and BLE is actually not compatible with classic Bluetooth. Now, the next is a low power Wi-Fi. Now, again, the Wi-Fi Alliance has recently developed a Wi-Fi Halo, which is based on your IEEE 802.11ah standards. Now, this in turn consumes very less power than compared to your standard Wi-Fi devices, also has a longer range. Now, this exactly is why it is most suitable for the Internet of Things applications for that segment. Now, any device that supports Wi-Fi also supports IP connectivity, which is very important for an IoT application for that matter. Now, the last is Zigbee. Zigbee is also based on the IEEE 802.15.4 communication protocol and is used mostly in personal area networks or PAN. Now, again, the range for Zigbee devices to communicate is very small, usually between 10 to 100 meters, and the details of the network and the application layers are also specified by Zigbee standards as such. Unlike the BLE, the network layer, which is part of the Zigbee, provides for multi-hopping routing. Now, when I come down to more details about the Zigbee network, I have three types, which is an FFD, full functional device, an RFD, reduced functional device, and one Zigbee coordinator as well. Now, with this, I just hope you have a simple understanding of how communication is essential for the Internet of Things architecture and the various ways that you can implement the communication between the devices as well. Now, the next concept or the next layer with respect to the IoT architecture is the middleware segment. Now, when I come down to the middleware, one of the key challenges or one of the key issues that comes into the picture is the interoperability as well as the program abstraction. Imagine I have 40,000 devices communicating with each other. 40,000 devices may not all use the same programming language or may not pass the information in the same way as well. I need to build or I need to have something that ensures that these devices communicate with each other and there is an abstraction maintained between the information passed from these as well. Now, if I have multiple devices also, what I need to ensure is that these devices are independently discoverable and I can manage each of them. Today, I need to be aware if one single sensor also breaks down because the information coming from the sensor is extremely important as well. When it comes down to scalability, it is extremely useful because when I need to grow my ecosystem, this middleware really comes into picture. If I can replace an existing middleware with something that can help me scale up, then I don't have to completely variate my entire ecosystem as well with respect to it. Usually, when I use a highly capable middleware, then it also lets me perform big data analytics and implement security and privacy as well. And this in turn usually helps me communicate with my cloud computing and also context detection. Now, again, when you come down to the middleware segment, you need to understand with respect to the various specifications of the application, which kind of database is it oriented, what is the semantics it's based on, what kind of events can it process, and what kind of service can it process or provide as well. These are some aspects that you need to keep in mind while you're selecting your middleware for your architecture. Now, the last layer is your application layer. Now, application is something that really is what your end user gets or is what usually maintains or helps process your information to the best that's out there. Now, this in turn can be used in different domains. It can help you achieve different things. It can help you have a smarter lifestyle. It can help you have a smarter environment. Your entire home system can be managed with respect to an application. Your car management can be done using application. You can build an entire social life and entertainment system based on a smart application. Now, although the end user usually only looks at the application layer, this actually is the front face of your entire architecture. Now, with this, I hope you at least have gotten an idea of what the entire skeleton of your IoT architecture comprises of. Now, what we've discussed here is just the skeleton. It's always up to the user to add in muscles to it and complete it with a skin as per your requirement.
Now, Raspberry Pi today has become so common that you can find it across most households as well. Today, it has become one of the most cheapest and common computing device that can be found almost everywhere. But let's actually go back to understand the ideology which brought Raspberry Pi into development itself. Now, Raspberry Pi basically was bought by the Raspberry Pi Foundation to introduce or to bring in the information technology back to the schools wherein students can learn how to program from scratch. The growth of technology today has grown to such a level that everyone today has ease of access to do anything on a computer. But back in the early and late 90s and 2000s, For using a computer, you needed to know how to program and how to work around with respect to it. So this in turn helped to build a very strong foundation for programming knowledge. And with the growth of UI, everything has become so easy that today you don't need to learn programming to do much. But at the same time, this has made it harder for people to identify and understand good programmers from those who are not. So in order to build a generation which starts with a very strong programming foundation and fundamentals, the main ideology was to introduce or take back IT to the basics and make it accessible across every school as well. Now again, as I said, it was introduced by the Raspberry Pi Foundation in 2012 as such. Now moving forward, what exactly is Raspberry Pi? Now this is one of the questions most of you would have across your mind as well, because you might have heard about Raspberry Pi but you might still not have a clarity. So let me help you clarify that right away. Now as per the definition, Raspberry Pi basically is a series of various small single board computers which actually have additional features as Bluetooth, Wi-Fi, USB capabilities, general input output ports and so forth. Now, it basically is a very small, low cost credit card computer which actually can be plugged into any monitor, as well as you can include a keyboard and mouse, and it increases the opportunity for people to explore, learn, and understand how to program as well. Now, the latest version of Raspberry Pi is Raspberry Pi 3, which was released in February 2016 as well. Now, Raspberry Pi basically is a combination of Raspberry operating system, and Pi, which basically stands for Python programming language. But before we move forward, let me just show you a very simple video which Raspberry Pi has put out so that you can understand the ideology of Raspberry Pi Foundation as well.
This is a Raspberry Pi. It's a credit card-sized computer that costs around £25, designed to teach young people to program, and is capable of doing all kinds of wonderful things. Back in the 80s, kids had to learn how to code computers to use them, and as a result, these kids grew up with an inbuilt understanding of how computers work. Now, we need more programmers than ever before. So to deal with this problem, some clever people came up with the Raspberry Pi to reignite the spark. It runs Linux, a free operating system from an SD card, just like the one in your digital camera, and it's powered by a USB phone charger. You just plug in a mouse and a keyboard, connect it to a TV or monitor, and you're ready to go. In schools, not only is Raspberry Pi a great way to learn programming skills as part of ICT, there are also dozens of cross-curricular applications, like science, and music. And all over the world, people are experimenting with Raspberry Pis and attending Raspberry Jam events, where people of all ages are learning what can be done with a Raspberry Pi. Since the first Raspberry Pi was shipped, we've seen examples of people using the Pi in a variety of amazing and interesting projects, taking advantage of its size, portability, cost, programmability, and connectability. So whether you want to learn to make games, build robots, or even teach a bear to parachute, with Raspberry Pi, the sky's the limit.
Great. So I hope you guys had a great learning experience with respect to that. That was basically the ideology of the Raspberry Pi Foundation on introducing Raspberry Pi into the market as well. Moving on, some of the capabilities that Raspberry Pi enables you to do is that it helps you to browse the internet as well as watch complete HD videos on the same device as well. So all you need to have is a HD supported display as such. Now apart from that, even basic operations like making spreadsheets, creating words, presentations, all these can be done on Raspberry Pi. And you have a huge set of games that are available which can be played on Raspberry Pi, making it quite interesting and easy as well for people to enjoy the component as well. Then you have various add-on capabilities like infrared cameras and security system which can be built keeping Raspberry Pi as the core hardware as well. Then you can also use music machines as well as detection of weather stations, which we actually had done in our previous session as well. Now these are just some of the top capabilities that I have picked up from the list. Raspberry Pi today has become one of the biggest components that has enabled users to achieve and create a lot as well. Today, the capability of Raspberry Pi is restricted just to your imagination. Whatever you can imagine can be done using Raspberry Pi given the amount of effort put into that. Now moving on, let's look at the Raspberry Pi hardware as well. Before that, let me show you how I would be using a Raspberry Pi as part of this tutorial session. So let me just give you a simple overview of the component as such. Now what you're basically seeing is that the Raspberry Pi hardware. So let me just switch over the camera and let me show you the Raspberry Pi. Now here what you're seeing is the Raspberry Pi 3 hardware as such, and this is your processor and system on chip, which is an Adreno A53 processor. Now two important ports here is the CSI port, which is the camera serial interface, wherein you can connect camera directly to the Raspberry Pi, and the DSI port, which is the display serial input port. Okay, now let me just flip this over slightly. And if you see, this is a 2.5 mm micro USB connector. So your standard mobile charger can be used to charge the Raspberry Pi, and this is a standard HDMI port for display. So your standard TVs and monitors which have an HDMI support can be used to become a video interface for that. Then you have an audio jack which is used to connect your audio inputs. Now let me just flip this slightly over and let me just zoom out a bit. Now if you see, we have an Ethernet connector, following which there are 4 USB slots as well. So when you see here, there's a 40 pin general input output pin present here. So this is something that's quite interesting and configurable from your Raspberry Pi software, where you can configure for what each purpose pins can be used, which we'll be seeing a little ahead. Now the final thing that I want to show you is behind here. When you flip backside, so there is a micro USB slot present here. This is mainly to insert your memory card, and when I say memory card, I would generally recommend at least a 16 GB memory card. This is mainly because the operating system in itself is about 4 GB, and if you use an 8 GB, then what happens is there's very less storage space for your operating system to work on as well. So a 16 GB memory card would be really helpful, and one thing that you want to see is this is an Evo class, which is something similar to a class 10 memory card. So if you're getting a memory card, make sure it's at least a class 8 or class 10 memory card, so that you can have high disk read and write processing. Now coming back. Now moving ahead, let's just skim through the various changes that has happened over the hardware of Raspberry Pi. Now we are not going to devote too much time into this because this is a completely in detail session. However, I would be stopping at these slides for 10 seconds. So if you wish to know more, you can pause the video and get a complete look as well. Now talking about the processor, the first generation of Raspberry Pi initially came with a Broadcom BCM2835 SoC, and it basically was similar to the first generation smartphone chips. And the architecture that was used also was an ARM v6 architecture. Now over the years, Raspberry Pi 3 has grown a lot, and today it has a capability of 1.2 GHz, which basically is because of the ARM Cortex A53 64-bit processor, and is considered to be 10 times faster in comparison to Raspberry Pi 1. Now talking about the change in Raspberry Pi over the years, as you can see here, the various models have been listed, and the architecture change has also been mentioned here as well. So in case if you are interested to know more, you can pause the video and take a look at this. Now when you come to the memory, the first model of Raspberry Pi came with a 256 MB RAM, and which basically was shared by the GPU. But today with Raspberry Pi version 2 and 3, you have 4 times that. You have about 1 GB of RAM, which again is shared by the GPU as well. Now the default split was at 192 MB RAM for the CPU basically, which was more than enough to play a full HD, that is a 1080p video, or perform simple 3D operations, but again not too complicated operations as well. Now moving forward, when you look at the networking capabilities, now in terms of networking capabilities, the Model A of Raspberry Pi did not have any such features, but from Model B of version 1 itself, you had an Ethernet port which was introduced here, and from version 3 you also have Wi-Fi and Bluetooth capabilities introduced here as well. Now talking about the peripherals in Raspberry Pi, there are basically 4 USB ports. Now this has been introduced in Model B version 1 plus onwards, and today you have a lot more that you can do with respect to that. Even audio input ports and audio output ports have not changed over the years, but the onboard storage has changed a lot with respect to it. Now again, when you look at the video capabilities, video controllers, basically here you can watch complete HD videos, but Raspberry Pi does not have a H256 decoding hardware. But the CPU in itself is way more capable and helps you in decoding the H256 encoded videos through software operations. Now in terms of GPU, the GPU in Raspberry Pi 3 runs at a higher clock frequency, which is about 300 or 400 in comparison to the previous versions, which was at about 256 megahertz. Now in terms of video input, you have a 15-port CSI connector that has always been present with the Raspberry Pi, and video output has changed over the years. You have a HDMI port, you have a DSI port, and now you also have a 3.5 mm TRRS jack as well. Now in terms of the connector capabilities, there are 17 pins of the GPIO ports which can be configured as per your requirements as well. Now, moving forward, these are the various details with respect to the general input output pin. This data has been taken from Wikipedia. So in case if you're looking for more information, you can definitely check out Wiki's page or the official Raspberry Pi documentation as well. Now, coming down, let's begin the Raspberry Pi installation process here. Parts. First, let me help you understand the different operating systems that are available at present. Okay, Raspberry Pi in itself supports multiple operating systems as such, but we'll mainly be working on Raspbian. Okay, so these are some of the most popular operating systems supported on Raspberry Pi. So you have RIS OS, you have FreeBSD operating system, you have NetBSD operating system. Plan 9 is again from Bell Labs, as well as Windows has its own Windows 10 of IoT version. Okay, so for this session we're not going to go into the Windows 10, we'll stick to the core Raspberry Pi operating system. Now for downloading the operating system, you can go on to the original site, that is raspberrypi.org, and there in the downloads tab you can download the operating system. Let me just show it to you. Okay, so this is the Raspberry Pi home page, and here if you go on to the download section, you can download the operating system. Now if you are starting off with Raspberry Pi and Internet of Things, trust me, this is the best place that you can find a lot of information with respect to it. Okay, most people actually publish their details with respect to the projects that they're working. Many popular projects are also available. You can find a lot of help as well as good information here. Okay, so this is definitely the place to go to. If you go on to the download section here, okay, this will either show you two options. You have Noobs or you have Raspbian. I would recommend that you go with Noobs because this is a complete package with respect to the different operating systems as such. So here again you have Noobs and Noobs Lite. So my recommendation would be you download Noobs and make sure you're using a 32 GB memory card. Okay, this would be really helpful because it gives a lot of memory for your operating system. So in case if you're going for a 16 GB or below, I would recommend you go with the Noobs Lite. But make sure you keep the bare minimum of 16 GB in case if you're working with Raspberry Pi. But do not mistake me when I say use a 16 GB memory card. You can install it on an 8 GB as well. But again, the operating system has less memory to work with. So at least go for 16 or higher. 32 is what I would recommend to. So once you download this zip file, or you can even download it via torrent. Okay, but I would recommend download it as a zip file. Let me show you the file. So this is the Noobs file. Let me extract this. Okay, it may take some time. Okay, it's about a 1.5 GB file. Okay, the Lite version is slightly lower in comparison, but this is something that I would recommend in case if you're working with Raspberry Pi. Okay, so I have my Noobs folder here. So what you need to do is that you need to copy everything inside the Noob folders and then paste it inside the SD card. Okay, make sure you're not directly copy pasting the folder that you have extracted. So what happens is if you do that, it does not actually recognize the operating system as part of the Raspberry Pi. So copy everything that you have extracted and then directly paste it inside the SD card. Now again, this is why I recommend that you use a high-speed memory card, because in case if you're not using it, then what happens is that it takes a lot of time with respect to fetching the data. Okay, now as I had mentioned, if you're going for a memory card for your Raspberry Pi, you can use something like a 16 GB at least and make sure it has a high transfer speed. So this in turn will give you a lot of memory area to work around with, as well as I would recommend you take something like a class 10 memory card that is available in the market today. So these have a very good read and write speed ratio. So definitely this is something that you should consider while you're getting a memory card for your operating system. Okay, now once we're done copying with this, let's go on to install this memory card onto our Raspberry Pi and let's begin the installation process. Okay, so now we've successfully copied all that is needed for our operating system. So safely remove this, make sure you're ejecting it safely. Because sometimes what happens is if you do not safely eject it, the files get corrupted before you load it into your Raspberry Pi. This is a certain issue with respect to the memory cards. So just eject this. Okay, so this is my Raspberry Pi, and if you actually flip it over, this is the slot where you have to insert the memory card. Now we've copied the noobs folder into this memory card. Again, let me just insert this into this, and let's begin with respect to the installation process. Let's begin installing this memory card onto my Raspberry Pi and start with the setup. So let me just turn on my Raspberry Pi. Okay, so this is the screen I'm getting by default. Now what happens is the installation steps initializes, so the Raspberry Pi is getting loaded. Now there are two operating systems that are present here by default, and we want Raspbian. So let me just select Raspbian and click on install option present here. Now if you see here, it basically is telling me that it requires 4.5 GB. So this is why I was recommending you to get at least 16 GB or more. Because if I have an 8 GB memory card, if 4.5 GB goes off with the operating system itself, then there's not much memory left for me to work around with. Now let me just click on install. Just before I do that, in case if you are using a different language or if you want to use a different keyboard as well, you make sure you're specifying that. Okay, so there are different languages present here, so choose the corresponding language as per your requirement. Once you selected that, just click on install, and this is just basically going to ask you whether you want to format your data and install the operating system on top of this. So click on yes, and the installation process has begun. Now it may take some time, so I request you to be a bit patient because this is an operating system installation process. So please be a bit patient and hope you have fun meanwhile. So now as you can see, the operating system installation has completed successfully. Once you hit on OK, it's going to ask me whether I want to reboot, or it would automatically reboot as well. Okay, so yeah, it's automatically rebooting at this point. Okay, now as you can see, the Raspberry Pi operating system has successfully been installed. Okay, so this is what your Raspberry Pi operating system would be looking like. Okay, so this is Raspbian as such. So there are different operating systems that are available today for you to install that we have discussed already. Now that we've installed Raspbian on our system, let's look at some of the accessories which can be used with Raspberry Pi. Now, one of the most popular and interesting accessory to Raspberry Pi is the Sense Hat. Okay, so hat basically is a hardware attached on top. There are various hats that are available, but SenseHat is the most popular because you have various onboard sensors present here. You have a temperature, humidity and pressure sensor present here, as well as a gyroscope and a joystick also present here. Apart from this, the reason that it is quite popular is because it has an 8x8 LED matrix display that is present to it. So let me just switch over and show you the SenseHat component as well. And okay, so here you can see the SenseHat. Now how it is slightly different from the other accessories is because it's got an 8x8 LED matrix present here, which can be used for displaying various things. And we will also be seeing how you can display this as well. Now coming on to the other components here. Now if you see here, it's already got multiple sensors here. It's got an accelerometer and a gyroscope meter present here. It's also got, which is this part, the accelo and gyrometer present here. So you can see it's got labeling as well. Then you have a humidity, pressure and temperature sensor on board with respect to this, and it's quite interesting and useful as well. Now, one of the easiest things with respect to this is that it can directly be placed on top of the Raspberry Pi's GPIO pins, and thereby making it quite easy to assemble it as well. So it directly sits on top of the GPIO pins as well. So this is something which makes the entire Raspberry Pi ecosystem quite easy and effective. One other interesting key point or factor that makes the SenseHat quite interesting is that it's got an onboard joystick as well. So in case if you are a gamer and you want to try out the games on Raspberry Pi, you can use this joystick as such. Now, another additional component that most people use with Raspberry Pi is the camera. Now, in 2013 itself, 1 year after Raspberry Pi 1 was launched, it had introduced the Raspberry Pi camera along with the firmware update as well. Now, the Raspberry Cam is basically an 8 megapixel camera and can directly be connected to the CSI port present on the Raspberry Pi itself. Now, it's also very interesting and can record up to 1080p videos as well. So moving forward, let's also look at the infrared camera. So this is a very interesting thing. So this was something that helps you capture video in infrared mode and is called Pi Noir. Okay, so again, these components can be bought online and is one of the most easily buyable. Now, the final accessory and one of the most interesting and essential accessory to the Raspberry Pi is the GURD board. Now, basically, it is used for educational purpose and it helps you expand the operations done using the general input-output pins here. So, using this, you can connect to various LEDs, switches, analog devices, sensors, and much more. This also helps you connect to Arduino, which is also another DIY hardware device which has gained a lot of popularity, but in comparison to Raspberry Pi, Arduino is still a growing stage. Moving on, let's begin with our Sensat tutorial. And what we'll be doing is we'll be exploring 5 different demos to understand how the Sensat component can be used effectively. Now, the first thing that we'll be doing is we'll be implementing a very simple code and we'll be trying to display a certain letter on top of the sensat. Okay, so I'm going to display E and D, but the value of that color is going to be generated by random. Okay, so let me just run you through the code that's present here. So the first line is from sensat import sense. So what it basically is doing is that it's helping you import sensat and establish a connection to the sensat component. We're going to use time for mainly sleep function and random for generating a random integer. Now what I'm doing is that I'm initializing the sensat, which is sense equal to sensat basically initializes it. Then what I'm doing is that I'm generating a random integer between the range of 0 to 255. Now for those of you who would have guessed why I'm doing this, definitely this is because the RGB value lies in this range. So it's somewhere between 0 to 255. Then what I'm using is that I'm using a sensat function which is show letter, and then I'm specifying which letter it needs to show, and I'm going to specify the color combination. So this is the RGB values present here. Okay, so it's going to show the letter E and it's going to create a random input with respect to that same. Okay, then it's going to sleep for 1 second, again generate a new random integer, and then it is going to show D. Okay, so again it will sleep and then it's going to clear. So let me just show you this to you practically. So now what I'm going to do is that I'm going to connect to my Raspberry Pi using VNC network. So it's a virtual network which I'm connecting it to because it's not quite easy for me to record the video on the Raspberry Pi. So I'm going to use VNC server for that, and I'll just give you a simple idea of how you can connect to VNC server to your Raspberry Pi as well. Now, one essential thing that if you are connecting to the VNC server, then you both need to be on the same network. Okay, so what I've done is that I have used a hotspot connected both my Raspberry Pi and my laptop to the same network. So in case you are wondering how to connect to your Raspberry Pi via remote server, this is how you do it. Just go to your settings, go to preferences, you have Raspberry Pi configuration here. Now in your interfaces, make sure that VNC is enabled. Once you've done this, then VNC server gets enabled, and onto your system just download VNC server and VNC viewer, and you can connect to your Raspberry Pi quite easily. Okay, so let me just show you the code which we're going to be executing. Now it's the same that we have seen earlier, so let me just make a small modification to this. So this is our code. Again, as we have seen, we are first initializing the sensat with sense equal to sensat, then we're generating a random integer, and then we're showing a letter E on that. So let me just change this, let me just set it to 0, and let me just copy this once more, and I'll also show a third combination here as well. So I'm just generating a random value between 0 to 255, and I'm displaying based on that color letter E, D, and F. Okay, so let me just save this once. So let me show you the output that is going to be displayed on the sensat as well. So let me just execute the program. Okay, now let me just switch over to the sensat so that you can see the output. It's a red E, a green D, and a blue F as well. So this is what? So based on the inputs that I have given, it has displayed a certain letter on the sensat LED display as well. So let's go back to our presentation and look at the next program that is involved here. So the next program basically is going to display an image. Now what it does here is that it basically is going to display an image that gives you a complete idea of the various color combinations possible on the sensat as well. So what I've basically done is that I've identified the RGB colors: red, orange, yellow, green, blue, indigo, violet, and E stands for empty, which is null.
Okay, and based on this I've created a random matrix here, but each of these values defines for a pixel of the sensat. Now as I have mentioned to you earlier, this is an 8 cross 8 LED matrix, so each of these values is for one of the individual pixels themselves. And with respect to how they start, the numbering starts from left top position, so accordingly it goes in a row by row manner. Okay, so let me just show you the output for this as well. So this is our program, and let me execute this and show it to you. And now let me just switch over to the Raspberry Pi. So here you can see the different color combinations that are present on the Raspberry Pi sensor. The first row was left completely empty. The next row has two R values present here. So this is how it has been defined. If you notice the code here, there are two R's following by three empty spaces. And before that also, if you can consider three empty spaces, that is one row. So every specific value is pertaining to one specific row as such. Now coming back to our presentation, so the third one is quite interesting. What we're basically going to do here is that we're going to rotate a letter based on the different orientation of the screen. So let me show you how this is done rather than just tell it to you. So what we're basically going to do here is that we're going to rotate a letter J on different angles as well. So we've defined the different angles 0, 90, 180, 270, and these are the various angles which is going to rotate for. Okay, I'm going to run a for loop where it rotates the same on different angles as well. So let me just show you that. So just let me add sense.clear here. Now the reason I'm doing that is mainly to ensure that the sensat is cleared after the rotation process. So let's execute this. Let me switch over to the Raspberry Pi, and if you see here, a J has been displayed and it's rotating. Okay, it has stopped, so let me just rerun this once again. So what is happening here is that I'm rotating the letter J by 90 degrees and it's completing two complete circles on the Raspberry Pi. Okay, so it's a very simple thing, but it's important that you understand how this is done, because what we're basically doing is that we're setting the rotation using the sensat. Okay, and then we're sleeping at 0.05 milliseconds as well. Now again, you can increase the delay here, you can change the letter here, you can even change the angle to understand how it works as well. So this is something that you should definitely explore about and get a better understanding with. Coming down, the next and most basic thing that you can do using sensat is that you can measure the temperature, pressure, and humidity. So we've already tried to do this in our previous session as well, where we've measured the temperature, the pressure, and the humidity. Now here I'm just rounding it off, and based on a specific value, I'm going to ensure whether the display is going to be red or green as well. So let me come back to my sensat. Let me just open the code, and we'll modify this on the go to get a better understanding. Let me explain the code once again. So first I'm establishing a connection to the sensat, then I'm running an infinite loop where I'm getting the temperature, the pressure, the humidity, I'm rounding it off, and if the temperature is above 36, so this is just a value that I have set, then the background color should be green and the color of the text should be complete white. Okay, so this is a simple modification I have made. Else in normal situation, if it is less than 36 degrees, then what it should be is that it should have a background color of blue and the text color should be yellow. So this is basically to help me identify the different ranges. Then I'm creating a message variable which is storing the following format, where temperature is equal to temperature value, pressure is equal to pressure value, and humidity is equal to the humidity value. Finally, I'm going to show this message on my sensat LED display screen. So let's just see how this works and execute the program. So let me just execute the program, and let me also switch over to the Raspberry Pi. So here let's begin with the execution of the code. So now you can see by default it is having a blue background and the text is actually in yellow. Okay, so if you would have noticed, the temperature is about 34 degrees centigrade. So to this, let it scroll once more. Let's just validate the value of temperature. You can also print this into the screen. You can also send it via an API and much more. So if you can see, it's 34.2 degrees centigrade. Now to this, what I'm going to do basically is that I'm just going to introduce a hot water source. Okay, so I'm just trying to raise the temperature here. So let me just shift it a little bit, and please keep a note on the temperature value. So the temperature has started rising. So it is taking some time. I think the water has cooled down a bit. Alright, so it's started. Now the color, background color has changed from blue to green, and the text color has changed from yellow to white as well. Now these can be used in critical measure environments as well. So let's say you are in a situation or an environment where you need to have a constant monitor and constantly be aware with respect to the environment change. In example like space or any other environment that you're working with, definitely these are certain things that can really be important and helpful as well. So coming back, let's just look at the last program of the Sensat tutorial, which is basically detecting the motion of the Sensat. Now, what I'm basically going to do here is that I'm going to rotate my Sensat, and I'm going to identify the value of pitch, roll, and yaw. Basically, these are the orientation with respect to the x-axis, y-axis, and z-axis, and this is just from the orientation of the Sensat as well. Now, this is mainly done using the gyroscope, but to get a better understanding and more precise value, we'll also try to include and incorporate the accelerometer as well. So let me come here. Let me just show you the program. So this is the program as well. So let me just stop the execution here. So as I had mentioned, this is going to run infinite number of times because the while statement here is indefinite. So let me just stop this and let me just run the orientation program. And let's just see the default values of pitch, yaw, and roll first. So now by default, if you see, pitch is about 0, roll is about 96, and yaw is about 0 itself. Now let me just switch over to the Sensat, and what I'm going to do parallelly is that let me try variating the value of the Sensat as well. Or let me try rotating the Sensat to give you a better understanding of how it works. Simultaneously, you can also see the change in pitch, yaw, and roll. So if you see here, I'm slightly lifting it, and the value of pitch has risen from 0 to 6. Roll also has changed, yawn also has changed. I'm going to try tilting it. Same, pitch, roll, and yawn also has changed. So I'm just tilting it with respect to various axes, and you can see the change here. Do you notice the changes? I definitely hope you do. Okay, so now let us actually stop the execution of this program, because this is also an infinite loop, and to same orientation program, let us actually try to incorporate the accelerometer and understand how more precise we can make. Now instead of just taking the pitch, roll, and yaw, I'm here going to directly take the value of acceleration. Here we had taken the value of orientation, and here we're going to take the value of acceleration. Okay, how basically it differs is with respect to the gravitational force that acts on this. So now let me just show you the code here. Now again, what you need to understand, the difference between gyro measure and accelerometer is just that it senses both the static as well as dynamic change with respect to that, but your gyroscope mainly measures the rotation of a specific device as such. Okay, so let me just execute this program as well. So let me just first begin by clearing the screen, and then we'll execute the code once again. So let's just execute the acceleration code to get a better understanding. And simultaneously, what I'll do is that I'll just show you how the change with respect to the axes, or how you, if you change the Raspberry Pi, how the value will also change. So by default, if you can see, the value of X is 0, the value of Y is also 0, and Z is 1. So now what I'm going to do is that let me begin by slightly rotating the Raspberry Pi. Now, if I change the Raspberry Pi into a vertical position like this, okay, so it's a perfectly vertical position. But if you notice the value of X, it has become -1. Okay, Y has become 0 and Z has become 0. Same time, if I rotate it in such a manner, I'm just keeping it on different axis, the value of X becomes +1 instead of -1. Same with respect to Y, if I change it in such a horizontal way, it is -1, and if I change it in such a manner, then it becomes +1. Okay. Now, if you flip it completely over, then the value of Z becomes -1 as well. So if this is the vertical position, then the value of Z remains 1. I hope this is clear for you guys. So again, these are all different parameters. Today, what I have done as part of this is that I've just helped you understand how you can explore the various parameters and various components that are associated to the Raspberry Pi Sensat as well. Now, how you use it and what you use it for is completely left to you. These are just some of the basic things that you can do using Raspberry Pi. The limitation of Raspberry Pi stops where your imagination stops.
Okay, now that we've installed Raspbian on Raspberry Pi, it's time we begin with the demo for this session. Now what we're trying to do is that we're trying to build a weather detection system to get the real-time weather analysis. Now when we talk with real-time analysis, it basically is the pressure, temperature and humidity. And what we want to do is that we want to get a live mobile notification for this. So for that we'll be first using Sensat board, which will help us measure the various metrics like temperature, humidity and pressure onto our Raspberry Pi. Then we'll use Raspberry Pi to transfer this data and display it on the Sensat as well. So we'll just be displaying the temperature as of now on the Sensat. And finally, we'll be using InstaPush API and Python program through which we can send this notification across the internet to our mobile application. So let's begin this demo part. First, let me show you what Sensat is and how you can assemble Sensat on Raspberry Pi.
Okay, so this is my Raspberry Pi unit, and this was what I was referring to. This is Sensat board. Okay, now if you see, this is a simple additional board that you can add on top of your Raspberry Pi. Okay, now it's quite simple, but how it's different is that in comparison to your Raspberry Pi, there is an 8x8 digital LED display present here. So you can use this for various different purposes as per your requirement. Okay, now it simply sits on top of the Raspberry Pi. Okay, just make sure the alignment is correct. And once you've done with that, just push it on top and the pins would merge accordingly. Once you do that, you can just place the 4 screws across the different ends and tighten it up. And once you're done with this, you can integrate and use the Sensat for various different purposes. We'll use Sensat to measure the temperature, the pressure, as well as the humidity across in this room that is present. Okay, so this has different sensors present on it and we'll be using them for today's demo. Okay, so let me just put this up, and once it's all set up, let's go back to our demo and let's begin with understanding the programs before we begin the execution.
Okay, so moving on, now that you've understood about Raspberry Pi, Sensat, and we've also installed Raspbian on our Raspberry Pi, let's move forward and start with respect to today's demo part. So again, going back, just to remind you, we're trying to create a weather control system wherein we're trying to measure the temperature, the pressure and the humidity around the sensor as such. Okay, so the first thing we're going to do is that let me just connect to my Raspberry Pi. Okay, so this is my Raspberry Pi interface. Now let me just show you the program as well. So I've divided the actual program into 3 parts so that it's easier for you to understand how this program works as such. Now the first program that we're going to execute is the sensing environment. So this is a simple program that's going to sense the environment variables, that is the temperature, pressure and humidity, and then it's going to correspondingly display these values on the Sensat LED display panel. Now let me explain this program to you one by one. Now firstly, we need to import the variables, the values on the Sensat. So for that we're going to use this line from sense_hat import Sensat. So this will give me the corresponding values from the Sensat to my Raspberry Pi interface. Then I'm also importing time. Now the main objective of time is to help me keep a log of all the values that I'm measuring. Okay, so that we'll be seeing a little ahead. After that, I'm going to assign the Sensat values to a variable known as sense. Okay, so through this variable, I'm going to correspondingly relate to all the values coming from the Sensat. Okay, moving forward, we have written a while loop, and this is an infinite while loop. So it's going to continuously measure the temperature, pressure and humidity, and it's going to correspondingly be displayed on the Sensat as well. Okay, so let me help you understand how the temperature, humidity and pressure are measured. Okay, so what you need to do to measure the temperature is use the function sense.get_temperature. So this function, that is get_temperature, will give me the temperature value measured by the Sensat in degrees centigrade. And here what I'm basically doing is that I'm just converting it into Fahrenheit. Okay, so the value in degree centigrade into 1.8 plus 32 is just a Fahrenheit representation of the current temperature. I'm using a round function to round off the corresponding value. I don't need any decimal point values here. I want a whole number. So what I'm doing is that I'm using a round function. And once I have the temperature, then I'm going to be storing it inside a temp variable. Okay, similarly, we're going to use sense.getHumidity and sense.getPressure to get both the humidity as well as pressure and store it in humidity and pressure variables as such. So basically I have all my three variables that are needed. Now what I'll do is I'll create a string called message, okay, into which I'm going to store the temperature, humidity and pressure with a specific notation. So T is going to be equal to the temperature, H is going to be equal to the humidity and P is going to be equal to the pressure. Now comes the part where I have to display this value onto my SenseAd display screen. Okay, so here I'm going to use the function sense.show_message. So this is basically a call through which I can send any message to my SenseAd display screen. Okay, now here I'm just passing the message with respect to the temperature, humidity and pressure variable, and then I'm also defining a scroll speed. Now this is something that you can play around with. If you want to have a faster scroll, you can modify it. I've chosen a 0.08 scroll speed. Then the other two factors are the font color and the background color. Okay, now the text color I have set as 200, 240 and 200. Now if you can guess, these are basically the RGB values for the corresponding text color. So this is something that I have set as per my requirements. You can play around. As well as background color is something that I have set to 0, 0 and 0. Okay, so you have the complete freedom to modify this as per your interest. I would definitely recommend that you try playing around with this to get a better feel of how it works. Okay. Now what I'm doing is that I'm putting my system to sleep for 4 seconds. This is basically to introduce a delay between the measurement carried out from the sensor. Now if I don't do this, since it's a continuously running infinite loop, it's going to keep measuring it one after the other. So I want a simple delay between the measurement. So I'm putting the system to sleep for 4 seconds. After that, what I'm doing is that I'm opening a file called weather.txt. Now here I'm going to create the log. Into this file, I'll take the present time and then pass the message as well. So these both with respect to the present time as well as the message are going to be stored in form of a log. Okay, so in case in future if I want to refer to the measurement, this is something that will be really helpful. Finally, I'm also going to print message on my console. Now this is something just for our understanding as well. We'll be seeing it on different places. We'll see it on the console, we'll see it on the SenseAd, as well as we will be seeing it inside the log file as well. Finally, I'm closing the log and then I'm putting my system to sleep for 5 seconds. So these sleep delays are just to ensure that the consistent values are being measured in a regular interval and there's no hindrance with respect to that. Okay, I hope you guys are clear with this because I'm going to go on to execute this program. So let me open my console. Okay, here let me write the command for executing a Python program and it's very simple. It's just Python followed by the file name. Okay, now in our case it's sensing environment. Okay, so let me execute this. And now if you see, the values are being computed and on the SenseAd the values are being shown as well. So you can see here the change with respect to that. Okay, firstly it showed me all the temperature, humidity and pressure, and now it's already come on the console as well. Similarly, it's going to have a simple delay, and then you can see already it's showing me the next values on my SenseAd, and it's going to be stored in a log file, and then it's going to come onto my console. So very interesting, right? So definitely you can play around with respect to the font, you can play around with respect to the background color, as well as if you are interested, you can try bringing different temperatured items near the SenseAd to see the variation with respect to that as well. Let's say if you have a glass of hot water and you bring it near the SenseAd, the temperature value will correspondingly change as well. Okay, so this is something that you can really experiment on and have a good understanding of how things work out. So let me just close this program and let's see the log file. Okay, so this is my weather.txt file. So I've taken different temperature measure variables. It's been logged from a long time that we've been trying this out on. So definitely there are a lot of values here. Okay, so let me just show you the latest value. So this is a range of values that I had just tried out some time back. So all the temperature and pressure log are being stored here continuously. Okay, and if we come down, this is the latest log that we have just created. With respect to the three values, this is the current status as such. Okay. So again, this is something that you can experiment on. I have just stored it because of my future reference as well. Okay, so I hope you guys have got a simple understanding of how you can connect to your SenseAd, measure the temperature, pressure and humidity, and also display it on the console as well as on your SenseAd. Now coming on to the second part. Second part is a slightly advanced version of the same program. Here we're trying to do something a little more apart from just seeing it on the screen. Okay, now I want to send an email with respect to all the logs that I have. Or let us say at a regular interval, I want to have an email which notifies me with respect to the present temperature and the current pressure and humidity. Now this is something that you can definitely use while you're working on a social experiment as such. Usually in laboratories, it's important that you always keep a check on the temperature, pressure and humidity. So this is something that you can try out. So let me show you the code. Alright, so here I'm just including something new as well apart from our previous code. Okay, now if you see our previous code is still present here. I'm taking the temperature, I'm taking the pressure, humidity, storing into a message, and then I'm also printing that message. But apart from that, I'm using a few libraries which are very essential for mailing me this detail. Okay, so for that I'm going to use first SMTP library. Okay, because your mailing protocols are SMTP based protocols. So these are something that I'll be using in case I need to send a mail with respect to all the details as such. So these are standard protocols through which I'll be communicating. Okay, now coming down with respect to what MIME is. MIME basically is an extension, a multi-purpose internet mailing extension, okay, through which I can send emails which support text characters, non-text characters, audio, video, images, and so forth. So sending a mail, this is an essential important library as such. Okay, moving on forward, let me explain you the code. Now, here we're repeating the same thing. We're also importing the time function, and then we are establishing a communication between the SendSat and the program. Okay, so here first you need to specify the from address, that is from whose mail ID you're sending this. So I have created two test mail IDs. One is edurekatest11@gmail.com. So from this address the mail is going to be sent, and the address which is going to be receiving this is Edureka Raspberry Pi. Okay, so from this email ID I'm going to send a log with respect to the data that is measured from my SendSat Raspberry Pi. Okay, then I'm going to use my MIME multipart function. From here I'm going to distribute my mail into multiple parts. So this is what your MIME multipart function will help you do that. So in my message part, the from is going to be the from address, that is from whom it is going. The to is going to be the to address, and the subject I'm defining it as temperature Raspberry Pi. So temp rasp. Then I'm measuring all the temperature as well as the pressure and humidity and storing it inside a message variable. So here what I'm doing is that I'm basically going to attach the message in a plain format to my message variable, which is going to be the details of the temperature and pressure. Okay, now let me come down and help you understand this part of the code. Now I'm going to establish a connection to my server. So I'm going to use a server variable wherein I'm establishing an SMTP protocol to Google. Okay, that is your smtp.gmail.com. So this is a standard mail protocol, SMTP. For Gmail it is smtp.gmail. For other mails you can just replace the corresponding mail. And then you have the port number. So again, with respect to SMTP, this is a standard port that you would be using for communication, that is 25. Okay, then I'm going to start my server. So that is server.starttls. Okay, once I start this, then I'm going to specify the login credentials. This is basically for authentication factor. So server.login, you have to provide the username and password. So my from address is my username and my Edureka API is the password for this email ID. Okay, once I've specified this, then what I'm doing is that I'm converting the message as a string. Okay, sometimes what happens is while you're trying to send this, it may not get sent as such because it has values also associated with it. So I'm directly converting it completely to a string, okay, and then storing it inside a variable known as text. Then I'm calling the function sendMail, through which I'm specifying from which address it is going, to which address it should go, and the text which is part of it. Finally, I'm quitting the connection between the server. I hope you've understood till here with respect to the program. Now it's time we execute this program. Okay, so let me call Python email.py. Okay, so now what it has done, now it's connecting to my server, that's the delay here. Okay, it's measured the temperature, it's measured the humidity as well as measured the pressure, and then it's going to send a mail. So let me show you this mail ID as well. So as you can see here, I've already received a mail from Edureka Test11. It's called temp rasp that we had set, and it's given me the corresponding value of temperature, humidity and pressure. So this is what I was referring for. So you can do this across. Now let me just show you my sent box as well. Okay, now if you see in your sent box, I can actually see that this mail has been sent. So there are two ways for me to verify this as well. So this is something that is really helpful for me. Now coming back to my Raspberry Pi, let us now see the final program in which we're going to incorporate this and do a little more. So let me explain you the code a little more better here. There are a few things new here. So first you have PyCurl and JSON being imported. Now PyCurl basically is going to help you establish a connection between your API. So we're going to use an API through which I'm going to pass my data. So for that I'm including PyCurl here. Apart from that, you have your string IO, which is a standard string input output management package, and you have your RPI.GPIO. So that is Raspberry Pi's general input output. I'm just referring to it as GPIO. Okay, so moving forward, whenever you see GPIO, it is the general input output from the Raspberry Pi. And then you have the similar function. You have sense underscore hat from sensehat and time function. And I'm establishing a connection here as we have done earlier between my sensehat and my application, and I'm clearing the screen on sensehat. Now what happens is sometimes if you've executed a program before and you've stopped the execution of the program, then what happens is the display will still have the remaining data present on it. It stays stuck on the sensehat. So before we move on to with respect to a program, we'll clear the data out. Okay, so that's what sense.clear does. Now here there are two things that are present here, hot and cold. Okay, now why they're being used, I'll come back to that a little ahead. Okay, apart from that, there's also a new variable known as push message. So we'll be talking about this also when we come down later, and you'll understand what the push message is used for. Now let's try to understand the code which will help me display numbers on my sensehat. Now you might be wondering, if I have already displayed number and data on my sensehat, why do I need a separate part of this code? Because here we're trying to do something different from what we have already done. So here firstly what we're doing is that we are setting an offset from the left and the top. Let me go back to my presentation here. Okay, now here this is the standard program that we are talking about, but let's see, this is what we need. Okay, so this is what we're going to explore ahead. Now this is my actual sensehat. Okay, this is an 8x8 LED display function. Okay, so here what I'm going to do is that I'm going to eliminate the first column and the first two rows from the top. Okay, so this distinctively will give me a 6x7 matrix area remaining with me. Okay, this is where I'm going to do all my operations from now onwards. So this is something interesting, and I'll help you understand why I'm taking this region. Now before we move on, let's take a simple look with respect to the code present here. Okay, now before I do that, let me try to help you understand why I've taken a 6x7 matrix area. Now this was the remaining area. I've divided this remaining area into two parts. Okay, I'm just going to give a gap of one column between these two, and the left hand side is going to represent the temperature or the value in tens place, and the right hand side segment is going to give me the value in ones place. So this basically is a 3x5 matrix wherein I have 15 positions to play around with. Remember this number again, this is 15 areas that I can play around with in a 3x5 matrix. Now let's go back to our code. Now let me help you understand how it works. Now I have basically 10 numbers with me. Okay, so each one is going to have a specific way of representing in a 3x5 matrix. So that's what I have written here in this number matrix as such. Okay, so each of the line is a representation of a corresponding number in a 3x5 matrix. And this 1 and 0 basically is the configuration for the LED to be either turned on or turned off. So normally when we write 0, the first line will always be full. The first three numbers are 1. Okay, then you have 1 0 1. Okay, again 1 0 1 1 0 1, and my last three numbers will be again 1. So as and when you represent 0 in a normal form, this is how you do that. So it may not be so clear to you right now. Okay, so what I would recommend is, before you try to understand how each of the numbers are displayed, set an offset on your sensehat. There, try playing around with respect to different values to understand how you can represent each of the numbers. Once you've made 2 or 3 mistakes, then you'll get a clear-cut understanding of how each of the numbers can be displayed. Now this is for a 3x5 matrix. Tomorrow you want to try it across the 8x8, you can do that as well. So definitely make sure to try out, make mistakes, only then will you learn. Okay, so each of the line is a representation for a digit in a 3x5 matrix. Now let's try to understand how we can display a single digit. For that I'm going to define a function called show digit. Okay, so this is the function. It takes a value as an input. Okay, it takes a value for xd. Okay, xd is the x coordinate for where the digit has to be present. Yd is again the y coordinate as to where the digit has to be represented. and the last is a simple RGB value present here. Now first thing what I'm going to understand is that I'm going to compute the offset position. Okay, why do I need to compute an offset? Because each of the numbers are present in different rows of the column. So I need to understand which is the present number and which value do I need. So for that what I'll do is the incoming value into 15 will always put me at the start of that row. Let's say the value is 3. Okay, so 3 into 15 tells me that I need to move 45 positions. So as I said, each row has 15. So 15, okay, then I have 30 in the next row. Okay, and once I'm done with the 45th transfer, then I'm here. This is the standard representation for 3. So I have this complete row at my disposal. Presently I'm pointing to the start of the 3 value. Okay, so this is something important to remember. So this is why we are computing an offset by multiplying the value into 15. So I have the complete access to this row. Okay, now we'll try to execute a for loop through which I'll place these values into the different parts of the LED display. Okay, now see, I have 3 cross 15 area, so I need to identify in which area should which value come. That is, which LED should be turned on. I have 3 rows and 5 columns, so I need to identify this. Let's go back. Now the first thing that I'm going to do is that I'm going to compute xt. Okay, xt basically is going to be the value of p modulo 3. Okay, this basically is going to give me value of 0, 1 or 2. Okay, so if you go back to our presentation, it's either going to start from this 0th position, or it is going to be in the first position or in the second position. Okay, similarly in the left hand side also it could be this 0th position, first position or second position. So basically we are dividing this. That's what you need to understand. Okay, coming back, let me just remove this. Okay, similarly I'm going to compute my y of t. Y of t basically is to help me understand which value should I take from this complete row. So this will basically start from 0 and go all the way till 14 as such. Okay, so it will basically represent which column value should I take. Okay, so I hope you understand. From this, which column value should I keep taking for my next value. Once I have this, then what I'll do is I'm going to call the sense.setPixel. Remember how we had called sense.show message? So therein we had sent a complete message. Now what we're doing is that we're just setting each of the pixels individually as such. Okay, so we're going to use the x coordinate, okay, which is going to be my xt plus xd. Okay, remember this. Okay, we'll define xd little ahead, but just keep this in mind. Xt plus xd is going to give me the x coordinate, yt plus yd is going to give me the y coordinate, and then basically my RGB number comes. So here I have just done a multiplication of p into r. So whichever I want, I'll just convert it accordingly. Okay, now comes the choice of when you have to display 2-digit number. So instead of going back to the same function, I have defined a new function which is called show number. Now show number is actually the original function that will be called, because the temperature measured is most often a 2-digit number. So this is where the actual code was going to start from. Okay, show number takes 4 values. It takes a variable called val, which is the present temperature. I have my RGB value, as well as I'm going to begin the function here. Firstly, I'll begin by taking the absolute value of the given input. Okay, when I say absolute value, I am basically trying to identify the number present in the tens place. Okay, so this is what absolute value will be. Whatever the digit is present in the tens place, I'm going to store it in my abs underscore value. So that I'm just providing it here to the tens place. Then let me also identify what is in units place, and this is simple mathematical operation where I divide the number by 10. I'm going to get a remainder, and that's what I want. So I'm going to use a modular division. So my absolute value divided by 10 is going to give me the units place as well. Now what I'll do is I'll run an if condition. So here what I'm going to do, if the value is greater than 9, then I'm going to call the show digit function which I had defined earlier, and I'm going to pass the tens value, okay, the value present in the tens place. So and then I'm going to also pass the xd and yd. In this case, xd and yd is going to be the offset left and offset top. Why? Let me help you understand here. My offset top is going to be with respect to this position. It's going to start from here. Okay, so it will point to the third row. Okay, my offset left will point to the second column here. So I know that this is where my tens place has to come. So that's why I'm passing it here. Okay, I also am going to pass the standard RGB value that I have got input here. Then for a second time, I'm going to call the show digit function, wherein I'll pass the units place, but with an offset of additional 4 spaces. Okay, so this, coming back to our segmentation, this is going to be 4 positions from our left. So offset left is going to give me the first place, but offset left plus 4 is going to be the start place where I have defined for my units place. When I say from top, it's both going to be the same because I'm not separating with respect to different levels. So I'm just going to change with respect to my offset left. Okay, so that's the only difference present here. Now coming down, we are computing the basic temperature, the humidity and the pressure, and then storing it into a message string. Now comes the place where I need to do my actual implementation. Now if you remember our problem statement, we have to send the pressure, temperature and humidity as a notification on our mobile device. Okay, so for that I'm going to use InstaPush, which is an application through which I can send notifications across my mobile. So my Python application, that is the final application, will communicate to InstaPush, and that will in turn communicate to my mobile application that on which I have configured it. Okay, so the notification will be received on my mobile application. Now coming down, let me remind you again why we are using this. In a real world scenario, this is something that is being used by NASA. Okay, there they're using it to identify if the exterior temperature is falling between a specific range, or even let's say if there's a change in the pressure inside the cabin, or if the humidity is too high. So all this can be measured and you can get notified with respect to any change that you want. Okay, now coming back to our program, this is why I have defined a range of cold and hot. If it falls below 37 degrees, I want a notification. If it goes beyond 40, I want a notification. So this is my range. By value, it should either be only 38 or 39. Okay, so this is why I'm using cold and hot variables. Now let me help you understand how the InstaPush application is working. For that, let me open my browser and show you how you can configure InstaPush for your Raspberry Pi application. Okay, so this is my InstaPush homepage. Okay, now first thing what you need to do is that you need to begin by creating a user ID credential here. And it is very important when you logging into your application, you use the same credentials. So make sure you do not lose this because it's very important. Only if you use the same credential will you get this notification. So remember that. So you have an option to sign up for free as well. Okay, all you need to do is provide your username, provide your email address, and then specify a password. Now let me just log in. Okay, so I'm just logged in. Okay, now here you can see there's already a timeline because I've already configured this application. Let me help you understand how you can do this. Now in my application, I already have a temp notify application, okay, which we'll be using as part of our understanding. Okay, firstly, let me click on add application. Now once I do this, I need to specify a name. So let me just call it sample. Once I click on sample, once I press add application, sample gets created. Now it is asking me to add event here. So click on add event. So let me call this temp rasp, okay, and then tracker would be message. Make sure you hit a tab here after you specify whatever it is that you're specifying, and here push message will be message. So make sure it's present inside curly braces whatever you're specifying here. Once this is done, just click on add event and this event is going to get added. Okay, so the event has been added. Now it's time I help you understand why I had specified message there. So remember, let me go back to my code. Remember we had defined something known as push message. So this is why I have defined message here. So this is what is going to be sent between my final program application and my InstaPush application. So this is why we had defined this variable earlier as well. Okay, now coming down with respect to this. Let me go back to my InstaPush and let me help you understand what all do you need before you move ahead. Okay, just go to the basic info tab, and here there are two things that you need. Okay, first you need your application ID and then you need the application secret. So this is very similar to how you have a user ID and password. So this is what you're going to use in case you're working with an application. Okay, so make sure you note this application ID and the corresponding application password. Now if you come back to my program, you can already see I have mentioned the application ID as well as the application secret, and here the push event is to my temp notify. So this was the previous event that was already set, so I'll be referring to that as well. Now what you need to do is that you need to use curl to post whatever data that you have to the InstaPush API. So for that you're going to use pycurl.curl function, okay, and this in turn will help you communicate between your application and InstaPush. Okay, so all the communication is going to be through a variable called C. Now c.setOpt. Okay, here what I'm going to specify is that I'm going to specify the URL first. Okay, the URL is going to be https://api.instapush.im/version1/post. Okay, there's also another alternative URL which is https://api.instapush.im/post itself. Now in case the other is not working, you can use this or vice versa. Okay, moving forward, I need to set up the customer headers basically for my authentication and content type specification. Okay, so for that you're going to use the command c.setTop followed by c.http header. Then I'm going to specify x-instapush-API ID plus my app ID, which I have specified earlier. So this will help me identify to which app this has to be pushed. Okay, the next is going to be x-instapush-app secret. So basically the app secret, your password in this case. Okay, then comes the content type. That is, what type of content are you going to pass? So this is going to be application.json. So I'm basically going to pass a JSON file to my API. Okay, so I hope you guys are clear till here. Okay, now what I'm going to do is that I'm going to define the function through which the message is going to be passed. Okay, so here what I'm going to do first is that I'm going to use a dictionary structure for passing the data as JSON in my post function. So JSON-field is going to create a dictionary, and through that I'm going to send this data. Okay, now what I have to do is that I have to specify the field values. So first comes the event, okay, which is basically what event I need to relate to. Then comes my tracker. Now I have not specified any tracker as such. Then comes my message, wherein I'm going to pass the push message. Push message basically is the temperature, the pressure and the humidity as such. Now if you want, you can print this, but I'm not going to print it here. Finally, I'm going to use json.dump to make a JSON file and going to assign it to post fields variable. Okay, so post field is the variable which I'm going to pass to my API. Okay, next, to send your JSON file with post, use the following command c.setTop, okay, inside which you're going to specify c.post field and you're going to pass this post field, which is the JSON file as such. Then if you wish to capture the response, then you can capture it inside a buffer. So for that, I'm also going to use a buffer.write operation, and this can be done with the following command c.setTop, inside which I'm going to write c.write function and buffer write. That is, the write back has to be into my buffer. Okay. Now if you want to be updated whether the post has been sent, then you can use the following command, that is c.setTop followed by c Verboros. So this will make sure that I am getting posted on my terminal with respect to the communication. Finally comes our operation of checking the temperature. This is very similar to what we have done earlier, where we are running an infinite loop. I'm measuring my temperature in degrees centigrades, I'm measuring my humidity, measuring my pressure, storing this value inside a message variable and then putting it to sleep. Simultaneously, I'm also writing into a log file, and this is going to be stored with respect to the present time. Okay, so till here I hope you guys are clear. Now comes the part where I've identified my temperature. I'm just making sure it's an integer, and then I'm going to call my show number function. Remember, we had defined a function based on which it is going to be displayed on my Raspberry Pi. So this is a call to that function. Okay, once I've done with this, I'm going to store it into temp1. Then I'll make sure that I'm writing it into my file, and then comes the interesting part. If my present temperature is either greater than or equal to the hot message, or if it is lesser than or equal to a cold temperature that we have defined. Remember the two variables we had defined earlier? This is where they are being used. Okay, the push message will start with either if it's hot or if it's cold. Following that would be the present values. Okay, the pressure, the temperature and the humidity. Okay, then what I'm doing is that I'm going to pass this push message to my P function that I have just defined. So basically it'll first convert the push message into a JSON data, and then it'll pass it through the communication. So this is what is happening here. Okay, same thing will happen in case the temperature falls below the cold range as well. Okay, then I'm going to create a JSON file and then call c.perform. So this basically will initiate the curl operation to start. Finally, to capture the response from the server, you can actually use the buffer range. Okay, so with this we've come to a conclusion. Let me just show you the final part of this. Okay, so make sure that you're closing the communication through curl. So use c.close. Okay, this will ensure that the communication done through curl is closed, as well as you ensure that the general purpose input output is cleaned up so that new values are being taken in. So now let's execute the final program. That's Python final program.py. Okay, now as you see on the Raspberry Pi, it's showing me that it's presently 35 degrees centigrade. Okay, I've started getting notifications on my phone. Let me just share this phone screen with you. Okay, and you can see there's a variation with respect to the temperature shown on the Raspberry Pi as well. Okay, let me show you first my phone screen. Now, if you see here, it's actually showing me multiple notifications being generated. Okay, it's showing me that it's cold presently. And here's the complete list of the temperature notifications. So I'm getting a constant notification with respect to the change in temperature. So you can see it's continuously being generated here as well. So this is something that is really helpful when you're working around with respect to a real-time scenario. So like I said, NASA extensively uses this for their own purposes of measuring the temperature, pressure, both in their scientific research area as well as the shuttles and space stations that they use on. Okay, so with this we come to a conclusion of our demo session.
Raspberry Pi has become the heart of the Internet of Things domain, and camera is one of the most interesting modules that you can add on to this interesting hardware as well. Now let's begin by exploring the Pi camera for that matter. Now, the Pi camera was one of the best additions to the Raspberry Pi component because this module has helped the users to use the perspective of camera into one of the smallest and the most effective component of the Internet of Things. Now, the main objective of the Pi camera module is to help you capture images, capture videos, time lapses, even slow motions as well. Now, apart from this, the Pi camera also helps you capture videos in full HD at 30 frames, HD at 60 frames, and even VJ videos at 90 frames as well. Now, there are two versions of Pi camera that are out there. Now, the latest version being the camera module version 2, which was introduced in 2016. Now, although there's not much of a difference between both these cameras, there has been a slight increase in the resolution, wherein you had 5 megapixels for the first module, you have 8 right now. And even the sensor on board has been swapped out, wherein there was OmniVision for the first version. Now it has been replaced by a Sony sensor as well. Now, talking about the Pi camera, you need to be quite careful while you're working out with the Pi camera. So let me help you understand how you can set up Pi camera with your Raspberry Pi as well. Now, there are 5 different stages on setting up Pi camera. We'll be looking at each one of them one by one. First, let me help you understand how to connect your Pi camera to the Raspberry Pi. Now, this is very important because we've used 3 camera modules and we've managed to burn out 2 of them. So please be careful because this is a very delicate ribbon and this is also a very delicate module as such. So let me help you understand how you can attach the CSI cable to the Raspberry Pi, and then I'll also help you understand, once you've done this, how to enable the camera as part of your Raspberry Pi as well.
So this is my Raspberry Pi camera and this is the version 2 of the camera. Now if you notice, this is the camera that you can see and this is something that's really delicate, so please be careful. Now one thing that I really want you to notice here is the connector here. So this is called the sunny side up and this is called the silver end. Now you need to be really careful when you're plugging this in. So let me just bring in my Raspberry Pi here as well. So here we have our Raspberry Pi 3 and I'll just show you how to connect this. There are mainly 2 precautions that you really need to consider while you're working with the Raspberry Pi camera. One thing is just please ensure that the Raspberry Pi is switched off or disconnected before you connect the Raspberry Pi camera as well. Now this actually leads to a high chance of blowing up your camera. We've already successfully managed to do that once. So please ensure firstly that the Raspberry Pi is switched off and also that the connection is correct. Now if you notice the silver side present here, this should be facing the HDMI port that is present here. Now in order to connect this, let me just slightly push it off, and this slot needs to be slightly raised up. You insert it like this. Okay, please be very careful. Once you've successfully inserted it, then just push down the hinge as well. This will lock it in. So make sure the silver side is towards the HDMI and the sunny side is to your 3.5mm jack side as well. Now it's recommended that you get a case wherein you can also support the camera because it's slightly challenging because the ribbon in itself is delicate
So when you get a case which has the camera support, it will be really useful to you as well. So it is a very delicate item, so please be careful while you're working with the Raspberry Pi camera module. Moving on, let's look at how to go into the interface and enable the Raspberry Pi camera module for your Raspberry Pi as well. So now that we've successfully connected to our Raspberry Pi, let me show you how to connect or enable the Raspberry Pi camera on your Raspberry Pi as well. Now, what I have done is that I have established a remote connection between my Raspberry Pi and my system using VNC Viewer as well. So this makes it quite easy for me to show you what I'm doing on my Raspberry Pi. So once you have successfully connected and turned on your Raspberry Pi, you can go into the menu and then go to the preference section. Here, go into the Raspberry Pi configuration, and what you need to do is go into the interface section here. Once you're here, make sure that you have enabled the camera option as well. By default, this would be disabled. Now I have enabled most of these for different purposes, so you can just enable the camera option as well. Once you're done with this, then we'll go on to the next stage, which is understanding how you can capture images from the Raspberry Pi camera and how to capture video from Raspberry Pi camera as well. Now, Raspberry still is actually a shell command which lets you access the camera module and capture an image. Now, the command for capturing an image is Raspberry still -o and name of the image that you want to store it as. Now, -o is basically to open the camera and capture the image. And at the same time, if you want to rotate the image vertically or horizontally, you just need to pass the parameter -vf or -hf. Now, both of this will either flip it vertically or flip it horizontally. And when you pass both of them, it'll completely flip it around as well. Now, apart from this, if you wish to capture a video from the Raspberry Pi, you can use the command raspberry-vid. Doing this will help you again capture the video from the camera module. Now, this is something that gets stored by default as a H264 video as well. Now, if you wish to convert this, you can use the following command, which is sudo apt get install -y gpack. Now, this video will actually help you install MP4 box onto your machine and help you convert your H264 videos into MP4 format as well. Now, once you have it in MP4 format, then it's quite easy to play this video and check it out as well. Now, again, if you want to run it for a fixed duration, then what you can do is that you can also pass the duration as part of the parameters while you're specifying raspberry-vid as well. Now, one thing that you need to keep in mind while you're doing this is that the time frame that you're passing here is in milliseconds. So please be careful while you're doing this. Now, although I'm specifying 10,000, it's only for 10 seconds that the video is going to be captured as well. Now, let me help you understand how you can do all this by using a Python function rather than a shell command as well. For that, what you need to do is that you need to install a package called PyCamera. Once you've done this, then you can easily access or you can easily perform all the operations as part of your Python program using the PyCam module as well. Now, what you need to do is that first you need to update all the packages that you want. Then you need to install the Python PyCamera package that's present. Now, if you have two versions of Python on your machine, then I would recommend that you run both these commands, that is Python-PyCamera and Python 3-PyCamera. This in turn will ensure that you have the 2.7 version as well as the 3.x version of PyCamera present on your machine as well. You can also install PyCamera using pip install as well. So the command is sudo pip install PyCamera as such. Moving on, let's talk about how you can actually create a program or how you can use a Python program to record the videos for the same 10 seconds. Now, earlier what I had done is that I had just mentioned that run for 10 seconds using the shell command raspberry-vid. But technically speaking, this does not really account for all the challenges that may come across while you're actually capturing a camera. Now, that is where you use a Python program to help you ensure that even if an exception is come across, then you can handle it. And to do that, we'll be actually using the with statement here. Firstly, what I would like to do, I would like to import the time package here. Now, importing the time package also helps me access to the PyCamera module, and the PyCamera function will in itself connect to the PyCamera module and the data that comes with it. Now, when I'm using with function here, this in turn will actually help me in handling all the exceptions and encapsulating the proper task and cleaning up the tasks as well. So it basically becomes a best practice while you're using the PyCamera or while writing any codes for that matter. So most of us programmers would like to consider all the scenarios and take care of it. And in this case, Python has given us the with statement to take care of it as well. Now, if I use the command camera.startPreview, what is going to happen is that it's going to give me a preview of what my camera is seeing. And I call a sleep for 10 seconds. This in turn will ensure that for the next 10 seconds, the camera preview is on. Once that's done, I'm going to stop the preview. So what I have here is a preview of what my camera is seeing for 10 seconds as well. But this is not where it restricts. There are various other commands that my Pi camera brings in as well. Talking about these commands, when I use the command camera.capture, it captures an image, and camera.start recording and stop recording will in turn help me capture a video as well. Now, if I go back to my previous program here I can also write camera.capture in order to capture the image between the 10 seconds. Or what I can also do is that I can also start recording at the same time as well. So I start a recording, let it wait for 10 seconds, and then I stop the recording as well. So these are different commands that you usually use together. Apart from this, if you want to capture a stream, then you can use camera.capture my streams followed by what type of stream that you want to store it as well. Now, if you wish to stream the video that is coming from your Raspberry Pi, then you can use the command camera.capture followed by my stream and the type of stream that you wish to store. Now again, this also can be recorded wherein you use camera.start record, it captures the stream, and you specify the quantization that is needed to this as well. Now again, if you wish to play with some of these properties of the camera as well, you can play around with the brightness, you can change the resolution, and you can even add a weight with respect to it. Similarly, as you have a timer function in your standard cameras, the same can be used here as well. So let's say I want to start the recording after 5 seconds, I can do that as well. Now with this, let's come to the demo of this session. Now this is a slightly interesting demo and I'm quite sure most of you are looking forward to this as well, wherein we'll try to help you understand how you can actually set up a security camera at your home as well. Now talking about the overall system here. Now here what I would like to do is that I would like to capture the image of anyone who comes to my door. Once that's done, I would check if this person is a recognized person or is it someone that already has access to the house. If not, I can always prompt my user and then give access to it. If not, I can deny access to it. Now, to those of you who've actually seen our IoT projects video, you would have noticed that in Mark Zuckerberg's section, he had actually allowed his parents. Now, I do not want to manually have to do this, wherein I'll just automatically allow people to do this as well. That's a smart system, or that's an enhanced system that we really would love to achieve as well. So we would not be completely able to achieve it, but we will take our tiny steps towards it, and we can all enhance it as per our requirements as well. So firstly, what we're going to do is that we're going to detect the face, we're going to gather this data, we're going to compare it, and then we're going to start recognizing data as well. Now again, this is a learning process that takes place. This is something that involves a lot of understanding, and this slightly gets interesting for most of you as well. Now when we talk about face detection, now the first stage of face detection is wherein a program actually decides whether an image has a face or it does not, and this stage in itself is called a classifier as well. Now in order to achieve this, OpenCV actually provides us with two pre-trained and ready to use face detection classifiers which are part of it. We have the HAR classifier and we have the LBP classifier as well. Now one thing that you need to notice, or one thing that you need to keep in mind while you're working with this, is that the classifiers themselves process the image while they are in grayscale as well, because it gives the machine quite clarity on whether to classify it or not as such. Now when I talk about each of the classifiers, whether I talk about the HAR classifier or the LBP classifier, each has its pros and cons. So let's actually try to understand this. Now the concept of face detection is not something that's quite alien to most of you, and I'm quite sure you've all seen it, be it in our Facebook application, Snapchat. Some of us have also seen it on the ATM machines as well, wherein face detection is incorporated. And if you wish the most simplest methodology, or if you want to see the most common example that's out there for face detection or face recognition, you can see it in most of the phones today as well. Now again, here what happens is that the two algorithms that are most widely used are the HAR classifier and the LBP classifier as well. Now again, both of these classifiers are mostly processing the images in grayscale, because we don't actually need the color related information to decide if there is a face or not. Now again, there are going to be two classifications present here. The computer program which actually decides whether there is a positive aspect wherein the face is present, or the negative aspect where the face is not present also. So this is how you decide, or this is what you call a classifier for that matter. Now in OpenCV, as we have seen, there are two different classifiers, which is the HAR classifier and the LBP classifier as well. Now again, when you talk about the HAR classifier, it is actually a machine learning approach that we take. Again, this was created by Paul Weiler and Michael Jones, wherein they had trained many positive images and negative images without faces as well. Now this in turn actually started helping them understand that extracting feature takes quite some time, And if you consider both segments, when you consider HAR and LBP, HAR actually takes up a slightly more time, but at the same time it gives you a slightly more precise solution as well. Now what it actually does, it actually considers the adjacent pixels to the region where the face is detected, and then it actually sums up the intensity of these pixels in each of these regions as well. Once it's done, it actually calculates the difference between these sums, and then it uses them to differentiate between the section and the subsection of the images as well. Now when it comes to the LBP section of this, here it creates a 3x3 window at the time of image as well. Then what happens is that it starts comparing from the center pixel with all the other pixels which are greater or equal to the value which you set as 1 or 0 as well. Then again it goes on to read the binary value in a counterclockwise order and converts it to decimal, which are center values of the pixel as well. Now what happens is that this process is completely repeated one after the other, and you have an easier or a smarter solution to this as well. Now again, as we have discussed, both of them have an advantage and a disadvantage as well. Talking about the HAR classifier, it has a very high accuracy when it comes to detection of face, and there's quite minimalistic false positive. But the challenge is that the computational time that it takes is quite slow, and again the training time that it takes is quite long as well. And even in dark segments, it's not quite accurate as well, because it requires high clarity with respect to the images or the scanning area that it takes into picture. But at the same time, when you look at LBP classifier, its computation and training time is actually quite fast and shorter when you compare to the HAR classifier as well. Now it is quite robust when to any illumination changes, that is when there's a change in lighting, it's still comfortable and capable of handling this. But at the same time, it's not quite accurate, or it's not on the same level, at the same time has a high chance of false positivity as well. Now, before we move on for ahead, let me just show you about these packages slightly better. Now, if you come into your OpenCV package, now I would recommend that you download the OpenCV library from GitHub itself. And if you come inside the segment and you go inside data, what you can see here are the different HAR classifiers and LBP classifiers. Now, if you go inside the HAR cascade section, here you can find different XML files present here, which will help you understand or help you recognize different aspects of a body. It can start from eye, it can start go to eyeglasses, and then so forward as well. Now what we'll mainly be using is that we'll be using the frontal face segment here. Okay, and again these are XML files, so even if you open them and if you see them, you would not perfectly get a clear-cut idea, but this is something that we have to use as part of our program as well. Meanwhile, while this is opening, let me go back, let me show you the LPP segment as well. Okay, now what you see here are different values that are associated. Again, these are different values to help you identify or help you understand how the face recognition should take place as such. Okay, now again, it's a very huge document. So what they're trying to do is that they're again going to try to restructure it again. I think you've got a simple idea at this point. So let me just close this and let me go back. Now, if you check the LBP cascade segment as well, here you have different segments. So again, what we'll be using is that we'll be using the frontal face segment as such. So what I've done is that I've just created a separate folder where I've kept my program and these two OpenCV files for different algorithms as well. Now coming back, we've done with our detecting the face. Let's talk about recognizing our faces as well. Now till here, what I've done is that I have detected my face, but I need to start recognizing this face as well. So face recognition mainly can be classified into 3 different steps. First step actually dealing with the data gathering stage. Now in this stage, what you're mostly going to do is that you're going to gather any relevant information with respect to that face. So usually this is done when you have multiple photos of a person, and then you start identifying or you start training your machine on this face, and then it starts recognizing this face every time that it comes up with an image of the same as well. Now there are 3 different functions that OpenCV provides us to do this, and let me give you a brief idea on each of them so that you know which to use where. Now first comes the Eugene faces. Now Eugene faces actually takes all the images at once, looks for all the important and useful components in these faces which are known as principal features, and then passes it on. Now, one key factor that makes, or one key challenge with respect to the Eugene face function is that it requires a good amount of illumination. But at the same time, when you have your Fisher face, here individually images or individually features are extracted rather than extracting one by one, and this in turn actually does not have a challenge with the illumination segment as such. Third is your LBPH, which is your low binary pattern histogram, and this is very similar to your LBP as well. But what happens here is that you create a binary matrix and convert into decimal factor, and then you actually plot a histogram with respect to it. So what happens here is actually a comparison with respect to the histograms that are present. So each face will have a correspondingly different histogram, and I just compare these histograms to in order to identify which face it is belonging to. Now let me come back to my Raspberry Pi, and before I go forward, as we said, this segment actually deals with two parts. First is actually capturing the detection, and the second is with the recognition part. So let me first show you how you can detect it. Now we've already discussed about detection or how to capture any intrusion detection in our Raspberry Pi 3 tutorial, where we actually captured someone opening the door and coming in as well. Once I've captured this image, then I need to start recognizing. Now firstly, let me show you this program here. If you want more details on how it works out, then you can definitely check out our Raspberry Pi 3 tutorial as well. Now, if I use the following code, let me just expand this a bit so that I think you may not be visible to you. Let me just increase the font size. Yeah, now I think you can all see my code as well. Now again, we're using different packages here. You're using user libraries, CV2, the time, and NumPy as well. Now I'm first going to set the first frame, then I'm going to decide whether there's any detection as well. Okay, now for this, as we have mentioned in our Raspberry Pi 3 tutorial, you can use the IP camera application, which is an Android application, and you get an IP address as well, or a URL, which I've specified here. Now let me just run this and show you what I'm seeing at this moment. Now what it's going to do also is that it's going to capture the last image that the camera sees as well. So any change with respect to it, it's going to overwrite until I quit or I exit from the program as such. So let me just run this. I'll just zoom in a bit. So let me go back to my desktop and I'll run the camera application. Now what it's doing is that it's connecting to my phone camera, and it's going to create or show you what I'm seeing or what my phone is seeing at the moment. So what you're seeing is my Raspberry Pi setup here. As you can see, it's set up on a curve because it slightly tends to get heated up, but you can see it's a separate device as well. So this is my first frame, and what I'm going to do is that I'm going to put my hand in front of it, and I'm going to make this as my last frame as well. While this remains, I'm going to press Q to quit from this, and it also has created an image called test.jpg here as well. Let me just open this, and if you see, it's my hand that has been captured. So what happens here is that it captures the last frame as well. So if you want to get a better understanding of which image it captures, we'll rerun this, but before that, let me just remove this file. Okay, so let me just send it to the waste bin, and then what we'll do is we'll just re-execute this program. I'll start by keeping my hand in the front of the camera itself. So this is my first frame. Okay, and any change to this, I'll just move it off completely. So this is going to be my last frame, and I press Q to quit from this, and let's just recheck the image as well. So you can see it has captured the last frame as such with respect to this. So it's a very interesting thing for capturing this. And now let's actually come down to our program, which talks about face recognition and face detection as well. So this is the program that will help me detect the face, train my application, and also understand which face belongs to whom as well. So I have imported my OpenCV2 because that is where my face detection and face recognition algorithms are present. I'm going to use the OS module here as well because I need access to the drives or the path where these images are going to be stored as well. And NumPy is one of the very key programs, or is one of the very key modules which is required for any face detection recognition as well, because the information that you're going to be using would be stored as a NumPy array for that matter. Now again, what I'm going to do is that I'm going to actually identify the faces of three people. Okay, I'm going to identify whether the image that I'm passing is of Ronaldo, is of Messi, or is of Robin. Okay, or if it does not fall into either of the three, it's going to give it as null as well. Now first program or the first function that we're going to be working is with respect to detecting the face. Now as I said, all the images are going to be converted into grayscale, so that's what I'm going to be using cv2.cvt color to grayscale conversion. Once this is done, I'm going to create a face cascade for that matter. Now cv2.cascade classifier actually specifies which kind of classifier to be used. Now for this program, we're going to be using the LBP classifier. Okay, and as you see, it's for the frontal face as well. We've seen there are different aspects, but we're going to be using LBP frontal face classifier as such. Now this face is going to store the list of all the faces that I'm going to be detecting or I'm going to be identifying. Okay, so for this, what I'm going to do is that I'm going to specify face underscore cascade, and then I'm going to ask it to detect in multi-scale parameter. So I'm going to say it has to identify in grayscale. The scaling factor of the image is set as 1.2, and the minimum number of pixels that it should consider is 5. Okay, now if no faces are detected from the images that I pass, then it has to pass the parameter as none. But if it is detected, then I want all the 4 coordinates with respect to the x and y axis, which I'm going to be storing in x, y, w, and h. Okay, x, y, width and height with respect to this matter, or I'm going to specify which part of the image does the face actually contain. So I'm going to specify with respect to the 4 coordinates that I'm going to be passing. Once this is done, then I'm going to define the next function, which is to prepare my data. Now, as we've seen, first comes detection, then comes preparing. When it comes to it, I need to specify the path from where it has to pick up the images for that matter. So let me come back. Let me show you where the images are present. Now, when you see inside training data folder, okay, I have actually 3 folders present here, which is my S1, S2, and S3. Now, if I go inside S1, you can see there's Ronaldo's photos. If I go back into S2, you can see there is Messi's photos. And if you see inside S3, there's Robin's photos present here. Now, let me come back to the code. Now here what I'm doing is that I'm passing the path, then I'm calling the face function as well as the labels. Now again, the face is going to hold the subfaces of all the subjects, and labels actually help me identify which it belongs to as well. Now what it's going to do is that it's going to run a for loop wherein it goes through each of the images present in the path. Now again, what we have decided or what we have started with the naming convention is with S123. So what it's going to do is that it's going to check if the folder name starts with S, because usually there are system folders separately. So it is going to check if the folder name starts with S. If it does not, then it's going to go into the next loop. But if it does, it'll check that folder as well. Then what it's going to do is that it's going to create the label for it, or it's going to identify which folder I'm present in. Now, if you actually go back to my training data, you can see I have specified 1, 2, 3 after this. So it's just to help me identify which label it belongs to as well. You can use any different naming conventions that you want as such. Then what I'm going to do is that I'm going to specify where the folder or where the images is present, which is actually one level inside this. So I'm going to go into the next directory, and then what I'm going to do is that I'm going to run a for loop for all the images that are present in this. If an image or a file for that matter starts with dot, because system files usually start with dot, so those are going to be ignored, but others are going to be recognized using my OpenCV, wherein I'm going to read the image first. I'm going to show you a message that says training on the data. I'm going to resize the image to a size that is comfortable for me, which is 400 pixel to 500 pixel. Okay, and then I'm going to wait for 100 milliseconds for that matter. Now what you can see here is that I'm calling the detect phase function, which is present earlier. So this again is a callback to the previous function where it goes up and it actually calls the previous function that we have created to detect the face as well. Once that is done, it's also going to revert with me the position as well as the face or the ID which it belongs to as well. Now if a face is present, then I'm going to append it to my face list, and I'm also going to add a label to this face as well. Once this is done, I'm going to destroy these windows, because again OpenCV creates a lot of windows, so I'm going to ensure that it's destroyed by doing it twice as well. This is done. I'm going to return the faces which I have and the labels correspondingly as well. Now what you need to understand is that here the faces here are of different players as well. So each of the faces present in each of these images is going to be segregated. It's going to store this into a location, and it's going to start training on them as well. Then what I'm going to do is that I'm going to prepare the training data. Now this again is something that is becoming a recursive function for that matter. It's going to be calling itself again, where it goes back, it goes to one level up, and it's going to keep calling itself until I have trained on all the folders which are present and all the images present inside that folder as well. So once this is done, what happens is that it prints me that data has been prepared, and then it also tells me the total number of faces and the total number of labels also present here as such. Finally, what I'm going to do is that I'm going to create our LBHB face recognizer. So for this, I'm going to call the LBHB face recognizer function. So if you remember, we had discussed about 3 different face recognition functions. We're going to be using the LBHB face recognizer function here. Once the function has been defined, then I'm going to pass these faces so that my machine can learn and train itself to identify these faces in future. Now, what I'm going to do is that I'm going to just create a rectangle across their faces so that it becomes a differentiating factor for them, or it helps them separate where the face is with respect to it. And once this is defined, or once I've created a rectangle across their face, again these x, y, h, z are the different coordinates of the face, and I'm just going to draw a rectangle across them. Again, I'm going to specify which color. So this is your RGB value, so it's going to be a green color box that's going to be defined, and I'm also going to print the name of the person present here. So what it's going to do is that it's going to identify which person it belongs to, and it's going to print it in Hensi plain. Okay, and what it's going to do is that it's going to be printed again in green color as well. Now now the most important function comes, which is prediction. Now in prediction, what I'm going to do is that I'm going to pass an image. The image copy is going to be created because we do not want to manipulate or work on a single copy of an image, because in case of any challenge or any issues, we do not want to overwrite or lose the image for that matter. Once this is done, then what I'm going to do is that I'm going to call the detect face function, which in turn will help me identify who the person is. Then what it's going to do is that it's going to predict the image using our face recognizer, and then it's also going to print the confidence or how sure it is that this face matches. Now what I want you to understand here is that if my confidence is below 30, that is, if I'm not sure that this person's image is correct or the face is detected, then what happens is, if it is greater than 30, it's going to draw a rectangle and then it's going to write who the person belongs to, and it's going to return this image for me on the screen as well. Now I have two images that I'm going to be passing here. If I just go onto my desktop, let me just show you. First is abc.jpg and the second is ron.1.jpg as well. So let me just show you the images. So you can see here I have ron.1.jpg, which is an image of Ronaldo, and I'm also going to pass abc.jpg, which is an image of Messi. Okay, so these are the two images I want to identify, and I'll be passing this to my program. Let me just run this program so that you get a full-fledged understanding of what we have written here and you understand how this works out as well. Okay, so once I've passed this image, then I'm going to call the predict function so that it predicts whose face that this belongs to or whose this face is as well. Once that's done, I'm going to destroy this. Now, I hope you've got a simple understanding of this. If you are interested in the code, please give us your mail ID. We will be happy to share the code with you as well. Now, let me just execute this so that you get a clear-cut understanding of this. Now let me just zoom in so that so you can see it has started picking up the faces for recognition. So you can see it's starting to prepare the data, it's checking out all the images, it's reading the faces, it's trying to detect the faces for itself. Now you can see total faces are 22, wherein it has identified 22 images, and it also has started to predict it, and it's given me the confidence of the face detection that it has taken place as well. Now the prediction has completed. For Ronaldo, it has successfully predicted the face, and it also has put in the text. And if you see for Messi also, it has done the same, but the text is very small here because the image has been resized for that matter. Okay, so it has successfully predicted this, it has detected it, it also has recognized it as well. Now it has also told me who this face belongs to as such for that matter. So this is how our face recognition system works completely. Now this is just one of a very minute or one of the basics examples of this, and if you want to create a complete full-fledged system, let me give you an idea on that same as well. Now if you wish to have a very great system or something that's really effective out there, something that's not too hard to build, then this is something that you should really consider. Place your camera, which is a wireless camera, on top of your door. Okay, use the Raspberry Pi to detect the motion. What would happen here is that every time there's a detection, Raspberry Pi would detect this happens, and then it would pass on this information onto the cloud. The reason for doing this is that it becomes quite faster and it's way more effective in that matter as well. Here the face would be detected, recognition would happen, all the information regarding these faces would be present on the cloud itself, and once it has identified that this is a valid user, then correspondingly it will allow the door to be opened as well. But what you need to understand here is that this in turn can also be configured for you to have an application or a notification sent on to your mobile application from the cloud as well, because most of the mobile application APIs for pushing information is very easily accessible and configurable on the cloud as such.
The Raspberry Pi has become the most popular platform for exploring the know-hows of Internet of Things. It is redefining the nuances for a new era of minimal operating software. And if it's about operating systems, you can be sure to find Microsoft Windows just around the corner. So we'll be talking about the Windows 10 today, but not the one on your desktops or laptops. In fact, not even the one on your smartphones. This Windows operating software runs devices even smaller than any of those. Now, if you've been tinkering with the Raspberry Pi, you must try installing the Windows 10 IoT core on it and know the operating systems that come as a part of the Windows 10 IoT. So Windows, that is fairly popular amongst operating systems, is now available for the Internet of Things. It is actually a revamp of the old operating system, Windows Embedded. But with IoT taking the world by a storm, the Windows 10 IoT is now its official operating software for all embedded things and systems. Now the Windows for Internet of Things comes in 3 packages. The Windows 10 IoT Enterprise comes for the embedded systems that draw more power and require more resources, like the bulkier systems in high-grade or industrial-grade machinery. The Windows IoT Mobile Enterprise comes for more minimal systems like the ones in our televisions or handheld devices. And the Windows 10 IoT Core comes for the smallest embedded systems in IoT, like even minute combinations of microcontrollers and microprocessors. So you can scale up or scale down these options according to your IoT devices and the requirements. Now the Windows 10 IoT Core is the smallest out of the 3 operating systems launched by Windows for the Internet of Things. It in fact is the smallest operating system that Windows has ever had. And you will be happy to know that this one comes for free. Now this Windows for small devices is so minimal that its interface is unlike any of the other Windows operating systems, and it is almost like that of a bare Windows kernel. But it is just about enough to power the things in IoT, run all of its applications, and ensure the seamless flow of data to and from the cloud. It also supports many other boards used in IoT development, but we'll be focusing on its installation on the Raspberry Pi today. Now its minimal interface is for better convenience, as whenever an application gets deployed to run on the Windows IoT Core, the Windows interface will disappear and all you'll be left with is the application running on it. Now this is because the Windows 10 IoT has been designed to run both headed and headless, which essentially means with and without a display. So your device becoming the application will reduce confusion while running headless. This also means that we can have only one active application running at a time, while there could be other background applications running. All that said, I think it's finally time we went over the installation of the Windows 10 IoT Core on the Raspberry Pi. So I have a Raspberry Pi 3 here with me already and a class 10 SD card of 16 GB upon which we'll be flashing our operating system. And please make sure that your SD card is at least class 10 and has a capacity of at least 8 GB. Without these, you might face compatibility issues with the Windows IoT Core operating system. Now the Samsung Evo or the SanDisk Ultra would be your best choices. So the first thing to do is to format the SD card. I recommend using the SD card formatter software that is available for free online. You could also use the default formatter on your system, but I'd avoid using it as it does not optimize the partitions required by the operating system and the storage on SD card, and it compromises on the entire capacity that is available. So go on with the SD card formatter. So it is really easy to get. We start by opening a browser and typing SD card formatter into it and hit enter. So you can go to the first link and scroll down once the website opens. So you can see SD memory card formatter download for Windows and Mac. Since we need the Windows operating system to flash the Windows IoT Core onto the Raspberry Pi, we'll be going for the Windows version of it. So click on it and your download should be initiated. So once your download is done, find the setup file and install SD card formatter onto your system. I've already done that, so I'll straight away go and open the app. And here it is. So you'll have to know which drive is your SD card mounted on. For that, we can go to my PC or this PC. So in my case, it is the F drive. So I'll make sure that the card is pointing to the F drive and I'll click on format. It'll give you an alert saying that erase all data on this card. Hit yes. There we go. Now we are ready for the Windows IoT Core download. So we go back to the browser and we type Windows IoT. So the first website is the official website for Windows 10 IoT Core. Once the web page loads, go to the download section and you can see there's a download link saying download the Windows 10 IoT Core dashboard. So this is what we'll be downloading. So we'll be installing the operating system through this dashboard itself. Let's go to the download folder, find the setup file, double click on it and click install. So it's a 58.1 MB file. So it is getting downloaded on the Windows 10 IoT Core dashboard, from where we'll be installing and flashing it onto our SD card. So once the setup is done, the Windows IoT dashboard should pop up automatically. If it does not, you can search it on your system as IoT dashboard and open it. So now with the dashboard in our system, we can start installing the Windows IoT Core onto our SD card. We can do that by setting up a new device. Let's click on set up new device. So once you do that, you can see a few columns that you will have to fill. So the first is device type. So I'm using a Raspberry Pi 3. So I'll choose Raspberry Pi 3. What OS build do I want? Well, I want the Windows 10 IoT Core. So I'll click on that. which drive is my SD card on. It's on the F drive. That's correct. And you can rename your device from here. Let's say I'm gonna name it min-win RPI, and you'll have to set a password for it. So I'm gonna go with RPI3 win10. I have to repeat the same, RPI3 win10. So now that the passwords are in place, accept the license agreement and click on download and install. So it'll give you a pop-up about erasing the SD card. Click on continue. So your downloading has now started. So you might get another pop-up, which is the IoT utilities trying to install on your system. Press yes. Then you should get a command line window where the OS will be flashed upon your SD card. So with that done, we finally have the operating system on our SD card. There will be another prompt asking you to format disk. Please hit cancel. This is very important. Do not hit format disk. Hit on cancel. That's it. It says your SD card is ready. So go back to your My PC. Make sure you eject your SD card. Once it is safe to remove, take it out and put it back in your Raspberry Pi. So the next thing to do is to connect all your peripherals to your Raspberry Pi and power it on. Now most operating systems will require you to configure some basic settings when you boot them up for the first time. But since the Windows 10 IoT Core is the smallest version of Windows, it almost has negligible settings to be configured. It will only ask you to set up your default language and if you want to connect to any Wi-Fi network. And that is it. So now upon starting the Pi, you should see the Windows logo. You can see the welcome screen for the Windows IoT 10 Core. Now since it has been designed for minimal and low cost devices, the configuration upon the first boot has also been kept minimal. So that does it. We have finally booted into the settings of the Windows IoT Core. So let us set the default language as English and hit next, after which it will ask you to connect to a Wi-Fi network. Let us say we'll skip this step and we can also do it later from the home screen or the desktop. So that's it. You've finally successfully booted the Windows IoT Core and it is ready for use. So here we have Cortana. You can record your voice for better speech recognition. I'll skip this for now and let's say got it. So this is your desktop for the Windows 10 IoT Core. You can see there's device info, which is mainly your home screen. It tells you the IP address and everything. There's a command line window. There's also a browser, and there are tutorials for you to make the most of the Windows IoT Core. There's a settings button. There's a power button as well. Now the reason behind your desktop being so minimal is that the Windows IoT has been designed to run both headed and headless applications. So to develop applications, you can do it on your laptop and then push it remotely onto your Pi, upon which the Pi will become that application. You can use the Visual Studio for it. So now you can go back to your IoT dashboard. Now the IoT dashboard also offers some functionalities for you to remotely control your Pi or your Windows IoT Core. So you can go to the My Devices on your dashboard and you can see there's a Raspberry Pi 3 with the name min-win RPI, the name that we gave it in the start. Now from here, you can open it in Device Portal to add extended features. You can launch a command line window. You can launch IoT Remote Client. You can shut it down. You can restart it. Plus, you can add another Pi to it. You can also connect it to the Azure cloud for intelligent analysis and advanced cloud computing. And also there are pre-packages which can directly be deployed to your Raspberry Pi. So you basically won't need Visual Studio. You will not need much of coding. You can directly download these pre-packages and run them to test the power of Windows IoT Core. So that's it. You can see the settings offers some basic preferences. There's network and Wi-Fi, there's Bluetooth, there's Cortana, there's a command line window, there's an internet browser, and there are other tutorials to make the most of Windows 10 IoT Core. So that will be all. I hope you followed how to install the Windows 10 IoT Core. Now looking at the rise in the popularity of Internet of Things, I've come up with this tutorial to make sure you people pick or purchase the right development boards for your IoT projects. Now the Arduino and the Raspberry Pi are your go-to boards for all things IoT. But how are they any different and which one should you be using? Well, don't worry. By the end of this session, you could be educating your friends on the same. But before we begin though, let me quickly tell you what exactly I'll be covering in today's session. So for those of you that are still confused on what these devices are, I'll briefly talk about these integrated circuit boards. Then we compare their hardware and software specifications, understand their modes of operation, check out their available boards, and finally conclude with the purpose that each of these boards have been designed for. So without putting it off any further, let's get started. Now, computers were a breakthrough in the world of machines, making the operation of any device or machine smarter than ever. And the motherboard in a computer is what drove these operations, either performing logical instructions that have been fed to them or calculating outcomes based on the information they receive. These motherboards let all parts of the computer communicate and act by utilizing the CPU and the memory. In fact, any peripheral connecting to the computer also needs to connect through the motherboard's programmable input-output connectors for their operation. Now, these motherboards are integrated circuits. And with the world trying to minimize the size of devices and make them more portable, we now have a variety of similarly capable circuit boards available to help us build smart equipment of our choice and according to our needs. Now, the smartest development boards today zero down to the Raspberry Pi and the Arduino. Both these integrated circuit boards might have a few things in common, but differ majorly in their mode of operation and capabilities. And if you've been experimenting with the embedded systems, or if the onset of IoT has got you playing with these integrated circuit boards, then you must understand the key differences between them and know the one that will be more suitable for your IoT projects. So let me begin by telling you that the Arduino is based on a microcontroller and is mostly designed to control the electrical components connected to the circuit board in any system, whereas the Raspberry Pi is based on a microprocessor that computes data and produces valuable outputs, and if required, it controls the electrical components in its system based on the outcome of its computation. So basically, the Raspberry Pi is a single board computer, but the Arduino is just a single board microcontroller. So let us start with the comparison by learning more about the hardware and software specifications of the latest models of both these devices. Now, the Arduino boards have a very simple hardware and software structure. The Arduino Uno runs on an 8-bit AVR 80MEGA328 microcontroller on a chip, which has a RAM of 2 kilobytes upon an EEPROM flash memory of 32 kilobytes and clocks a processing speed of 16 megahertz. On the contrary, the Raspberry Pi boards have a complex architecture of hardware and software. The Raspberry Pi 3B Plus comes with a powerful Broadcom BCM2837B0 microprocessor on a chip as its central processing unit, which runs on a 64-bit quad-core processor called the ARM Cortex A53, featuring a static RAM of 1 GB running directly upon the SD card storage at a clock speed of 1.4 GHz. Now, this microchip also acts as the graphics processing unit with the Broadcom Video Core 4 integrated graphics card built into it for low-power multimedia processing. Now, such a multi-utility microchip is being called a SoC or a system on a chip these days. And besides the processor and the graphics card, they also house other microcontrollers to control their electrical components. So there's plenty of power packed into it even for many add-ons or USB connections. Now, most of the other hardware are pretty much the same for both these devices, like timers, voltage regulators, serial peripheral interface buses, inter-integrated circuits, serial UART, and I/O pins or connectors. But again, the I/O connectors in Arduino are more capable than the I/O pins in the Raspberry Pi, which must depend on transistors to drive external hardware. Now, the Raspberry Pi is still better at logical processing, which means it can compute even complex mathematical operations, enabling it to process and support audios, videos, images, and other GUIs. So it's more like a computer in contrast to the Arduino, which can only control parts of a device and would need additional circuit, software, and communication buses to run audio, video, or any visual graphic at all. Plus, the Pi also offers HDMI support, so all that you'll need is just a screen or any display device, removing the need for connecting it to a computer all the time like with the Arduino. Now, this is because the Arduino comes without any operating software. The only little software it has is for compiling code to machine level and allowing serial connection for data transfer. This is also why it requires less power and could even operate faster, as it only needs to compile code and use the chip directly to control any component. Whereas the Raspberry Pi must enable all required layers of software and utilize different programs to make any task happen. Then again, it is also why the Pi can multitask, doing a variety of tasks at a time, while the Arduino can perform any single task multiple times. So the Arduino offers an IDE with the compiler and is the only one that this device supports. which means only the codes written here will work and get compiled onto its physical board. This IDE uses basic C and C++ paradigms and breaks down all its functions into accessible packages, making it quite easy to learn and operate. However, with the Raspberry Pi, which supports multiple programming languages and software environments, you'll need to be proficient at coding to get the most out of it. Also, the Pi now comes with Bluetooth and Wi-Fi support for remote connections. In fact, its latest model features faster Ethernet, a dual band of 2.4 GHz and 5 GHz wireless LAN, and an inbuilt web server. While the Arduino features Bluetooth on just one of its boards called the Arduino BT and will require additional circuit for communication over wireless networks or Ethernet. Now, these additional circuits for the Arduino are called shields and are attached to it for extended functionalities. Similarly, in the case of the Raspberry Pi, these extended circuits are called hats. Both are plentifully available, housing diverse functionalities, sensors, motors, actuators, and software on them for interacting with the physical world and driving external hardware according to its host device's capabilities. Okay, now I can see somebody has a question. So Debbie wants to know, what is the most popular programming language that is used for coding with the Raspberry Pi? So since the Raspberry Pi is essentially a computer, you can actually run code on it in almost all programming languages. But the most popular one, in my opinion, would be Python, as even the Pi's official operating system comes with the default Python IDLE, which is the IDE for Python. So I hope that clears your doubt. If there is any more questions, please keep it coming. Okay, meanwhile, let me move on. So let me now tell you how you can identify the purpose behind using either an Arduino or a Raspberry Pi. So the Arduino, being more of a microcontroller motherboard, is best suited for repetitive tasks like reading and reporting temperature, opening and closing of doors, controlling lights, or building motion detecting alarms. It also works great for creating quick and lightweight prototypes. But the Raspberry Pi is more like a general purpose computer and is good at complex calculations or performing multiple tasks or processing a large amount of data. So if you need a full-fledged computer on a very small scale, the Pi is what you should be looking at. So let us now move on to the different boards that both have had over time and look at some of its prominent ones. So the Arduino has been around for quite a while now and has had multiple boards over the years with different functionalities. Although the Arduino Uno, the Arduino Mega, the Arduino Lilypad, and the Arduino Bluetooth have been the more popular ones. Similarly, the Raspberry Pi, despite being relatively new, is on its third generation, with each of its models better than the previous ones. The Raspberry Pi 3B Plus is its latest and most powerful development board yet.
In this session, we will be talking about the top 7 projects which are outstanding themselves in the Internet of Things domain. Now let's talk about each of these projects. Let's start with number 7, which is a biometric system. Now, a biometric system is something that we always encounter on our daily basis as well, because we always either use a fingerprint sensor or we use an iris scanning. So it depends from organization to organization. But how does this actually work? The system there, let's take in case of this example, has a fingerprint scanner. Now, the first time that I'm presenting my fingerprint, it scans the fingerprint and considers this as part of an enrollment process. From this fingerprint template, what it does is that it extracts certain key features which makes it different from others and stores it into a database. From then forward, every time that I place my finger on top of this fingerprint scanner, it creates a template and compares this with all the templates that's present in the database. If it matches, then it correspondingly, let's say, gives me an attendance or lets me access a door. If it does not, then it raises an alert with respect to that same. Now, this is just a foundation. Now, as I said, this biometric system can be fingerprint, it can be iris scanning, or it can be a combination of both as well. Voice recognition system is one of the key products in the biometric domain. Next, we have smart irrigation system. Now, I am someone who personally likes gardening a lot. Now, this is something that would really make my life easier, because usually what I do is that on Sundays, I spend about 2 hours just watering and looking after my plants. Through a smart irrigation system, what it does is that it checks the moisture present in the environment or in the water lanes that I have created. Now, to help you understand how it works, usually there are 2 main Internet of Things devices that are used here, which is the Arduino board and the Raspberry Pi. Your Raspberry Pi becomes the main processing unit, and I place an Arduino board for each of my water channels. These Arduino boards themselves are connected to multiple sensors which are part of this water channel. So what these sensors do is that they check the moisture present in these lanes as such. So let's say a specific lane does not meet the minimum required moisture, then what it would do is that it would send a signal to the Raspberry Pi. Again, all these devices are connected on the same wireless router network, and the Raspberry Pi would identify the lack of moisture and pass a signal to the relay. The relay in turn would initiate the water pump and water would be pumped. Now, in order to ensure that water is not wasted, we would create gate controls, and only the gate where the moisture is less would the gate be open. Once my sensor detects that the moisture level has gone beyond my required level, it would again send another signal to the Raspberry Pi asking it to stop the pump as well. So this in turn helps you to save a lot of water and also makes your life quite easier as well. So after this, your only task in your garden would be either setting up new plants or creating new water channels as such. The next project in our list is a security camera and door unlock system. Now this is something that's quite interesting, and I've personally tried this out, and it's really something that you should try out as well. Here what happens is that you place a camera on top of a door, which in turn clicks the photo of a person who comes into the frame. Now this photo is again sent to an analytical system, which in turn compares this with all the photos that it possesses in order to identify whether to let the user open the door or not. Now an evolution to this is that if it does not find the photo of that person, it can notify the concerned person that so and so person is trying to access this door. Would you like to authorize this person and add his information to the database, or would you like to deny the access to this person as well? Usually this is used in areas where you have high sensitive information stored in order to maintain a strict control to the access to this information as well. Another usage of the security camera and door unlock system can be even at our homes, when we can identify who's come at our home when we're not there and either decide to give them access to our homes or not. Now the next thing is something that we all really desire to have, which is a smart home system. A smart home system can be something that really makes our life quite easy. Starting from energy management, where the light control systems, the AC, the appliances that we use, the thermostat, all this is managed. In short, trying to cut down the power consumption that's taking place. My door management system is also part of this. My security system is also part of this. My water management system again becomes a part of this as well. Again, these are key things that really stands out in the smart home system. But again, what I would personally recommend is that a smart home's limitations is where our imagination stops. Anything that you wish to automate or wish to make your life easier can be part of a smart home system as well. Now, a smart home usually is going to be a base for our next project, which is a smart city. A smart city is an evolution of a smart home. Here, it's not just the sensors of a single home that is connected. Here, it's a correlation or a network or a connection between various organizations, various domains, as well as various segments of that city as a whole as such. Here, the life of every single dependent person in that city becomes easier as a whole as well, and in turn will really help develop that city to greater extents as such. Now, the key factor here for a smart city is a government support as well. And if governments are really willing to take this step, then I hope we would see a smart city completely built on Internet of Things, maybe in the next 5 to 10 years as well. Now, the next project is something that really stands out on a personal level. This is Zelda's Ocarina controlled home automation system. This is personally something that I feel is the closest to a smart home system, where most of the elements of the home is completely controlled by an ocarina. What Alan Pan has done here is that he's created a node-based recognition system which completely automates his home. But rather than telling more about this, let's just look at a quick video which will give you a glimpse into how he has done this and what has he done. Next on our list, at number 1, if you've not already guessed, is Jarvis. Jarvis is the artificial intelligence system that Facebook's creator Mark Zuckerberg has built for his home automated system. I'm quite sure you've already seen the video of Mark Zuckerberg interacting with Jarvis, which has Morgan Freeman's voice. And if you've not, here's a quick glimpse into the same.
Good morning, Jarvis.
Good morning, Mark. It's Saturday, so you only have 5 meetings. Room temperature is set to a cool 68 degrees.
Earlier this year, I started building a simple AI to help run our home. I talked to Jarvis using this app I built. It uses artificial intelligence to understand me and figure out what to do.
Max woke up a few minutes ago. I'm entertaining her.
All right, let's go check on her.
Good morning, Max. Let's practice our Mandarin. Ning yu, xiao shong mao.
Jarvis, your Mandarin is so soothing.
Xie.
Jarvis also helps me get ready in the morning. Fresh shirt.
Fire in the hole.
Hell yeah. Jarvis knows when to make me breakfast.
Your toast is ready.
All right. It's time for my call with Shrep. Can you get him on the video conference line?
Setting up the VC room now. Remember to check on the AI guidance system for Aquila.
One of the best things about Jarvis is it could recognize people at the gate, let them in automatically, and then just tell me about it.
Mark, your parents are coming in.
Thanks, Jeffrey.
It's Jarvis.
And Jarvis can play all of our favorite music. Hey, play us some good Nickelback songs.
I'm sorry, Mark. I'm afraid I can't do that. There are no good Nickelback songs.
Good. That was actually a test. Okay, how about just play some songs that our whole family likes?
The itsy bitsy spider climbed up the water spout.
What? I'm a dad now. This is what I listen to.
Now, what you need to understand here is that Internet of Things is not something that's just dependent on a sensor or a few sensors which is connected to a Raspberry Pi on Arduino board. When I look at the entire architecture of IoT, this is a complete ecosystem wherein my sensors gather information which is again stored on a platform and then processed on this. Now, if there have been any issues or failures that have been reported by these sensors, then I need to create actionable items in order to ensure that this is never really repeated again. But the information, once it's been processed, the processed data is then passed into machine learning and artificial intelligence in order to understand, analyze, and identify various patterns that's out there and help pass this information on back to the sensor. This in turn helps you have a better experience and also improve the system as a whole. A system where I come home every day at 8:30, start off my AC, wait for 15 minutes for it to cool down is a tedious process. But say today my Internet of Things platform identifies this pattern, already switches on the AC at 8:15, then I just need to come home and I can relax right away. This is just one of the key examples or one of the key ideas that's out there today. And the limitation here again is just your imagination.
It is so good to see that so many of you are keeping up with the trends of technology today. So let us dig deeper into these devices that mark the beginning of every IoT ecosystem and look at the best ones in use today in different domains. But before we start though, let me quickly run you along the outlines of today's session so that you have a clear idea on the topics that I'll be covering. So first I'll be telling you how you can identify any object to be an IoT device. Then I'll tell you what they can do for you and cite some of the major use cases in it. And then I'll tell you how IoT devices are shaping the entire world and quote some leading examples. And then I'll tell you how secure is a device in IoT. And finally, I'll be telling you all the important things that you need to know to build an IoT device. So without putting it off any further, let us begin our session today. Now, these devices that play the role of things in IoT are what make the smartest systems possible today, be it just a smart appliance or an entire smart city. It could be complete computing devices designed keeping their portability in mind, or tiny electronic components operating on minimal device software for data transfer and connectivity without any computing abilities at all. And there are also objects that are not made up of any electronic hardware at all and can still become the things in IoT by having these smart things attached to them in some or the other way. So what I'm basically saying is that even we humans can become a thing in the Internet of Things. But again, that is a contextual term, and you'll understand why as we move on with the session today. So for now, we can just say that any device, however puny or powerless, with the ability to receive or send data, allowing it to communicate over networks, can be called a thing or an IoT device. Also, it should be serving a purpose, like either collecting some information or delivering some outcome. Now, that is the least any IoT-enabled device or thing in IoT will require today. Even though the bigger devices have diverse features and can be more powerful, it is the miniaturizing of computer hardware that has truly given the Internet of Things its edge in the market today. It has made it possible for these IoT devices to even function at microscopic levels in the remotest corners of our world, and has also brought in focus on more target-oriented features specific to their goals. Plus, with devices running on incredibly low power levels and operating with such minimal resources, the things in IoT come with the promise of implementing solutions in the most cost-effective way possible without compromising on the system's accuracy. This is because at their smallest levels, these things are embedded with just enough technology for them to communicate over the internet and other networks to get the data analyzed, stored, and processed over that network or over the cloud, rather than physically housing all those technologies on themselves. Also, such low power levels are perfect for the little chips, sensors, and other low energy components that these devices use for their operation. But like I said, they're substantially equipped to connect wirelessly for exchanging data and performing actions based on them. Also, such low energy modes of connectivity make it easy for these things to operate just about anywhere while letting us control and monitor them remotely for almost any part of the world. So it is as if the British technology pioneer Kevin Ashton, who coined the phrase Internet of Things back in the 1999, somehow knew of these potentials that IoT brings out in devices today. So let us move on now. So let us see what things can do for you. So one of the most popular implementation of these things and their applications have been in the sector of home automation today. The use of Internet of Things in this industry has got the world closer to achieving a dream home powered by the smartest systems using these IoT devices. And these systems have been built such that all its devices can intercommunicate to allow owners a customized access to all aspects of your home, like your lights, your locks, or the inside environment, or security cameras, or even your total energy consumption. With the brand-specific IoT platforms and clouds behind them, these IoT devices are now capable of exhibiting ambient intelligence and also stay connected to the internet for driving real-time operations. So let us get into some examples of IoT devices used in most smart homes today. And we must begin with the tunable smart lighting systems like Philips Hue Smart Home Lighting or the TP-Link multicolor smart Wi-Fi that can be easily controlled using your smartphones with the option of creating custom lighting automations from anywhere in the world by just being connected to the internet. With smart lights like these, you could turn them on or off anytime and tune the color and the brightness of lights in your homes remotely no matter wherever you are. Moving on, did you know that locks and keys are getting old-fashioned nowadays? No, it's not a joke. Smart locks are a part of almost every smart home today, and the August Smart Lock 3rd generation is one of the newest and the hottest ones on the market today. What makes it stand out among its peers is that it comes with Bluetooth support, so that you won't need to worry even if your internet is down somehow. With a device like this that attaches to your existing deadbolts, you'll always know if your door is completely closed and locked. With its door sense technology, it'll even remind you to lock your doors when you're leaving or tell you if they were properly closed or not based on the location of your phone. You can even create secure virtual or temporary keys for your neighbors and guests just in case. Now the next IoT device is the Nest Learning Thermostat. It is one of the best examples of an IoT device today. As a part of your home automation system, this intelligent device learns your schedules and preferences over the first couple of weeks to smarten the cooling and heating systems in your home and then regulate your home temperature automatically to save your electricity by 20% among a ton of other features. So to reduce your energy bills, it uses sensors and your phone's location to realize the weather, the time, or the environment inside, and when nobody is home, it'll shift into energy saving mode. Apart from the thermostat, Nest also provides smart cameras with smoke and carbon monoxide alarms to better manage your home's atmosphere and its security. Plus, it lets you manage and monitor each of them through its dedicated app or even build your own revenue channels upon them. There is also one more device that I think is worth a mention in the home automation systems of today. It's mostly just a doorbell for your front doors, only a lot smarter. The Video Doorbells by Ring is a modest name for all the things that it can do. It's like you're always home, as it lets you answer your door from just about anywhere. It'll in fact even alert you of motion within 30 feet of your door and stream its live footage onto your phone. And if somebody rings a bell, you can let them know that you're not home and even have a word with them. With its night vision, the wide-angle high-definition recordings get simultaneously saved to a cloud for your use anytime. Now, before I tell you what else IoT devices can do for you, virtual or home assistants like the Amazon Alexa, the Google Assistant, Siri, and Jibo are also a trending application of the Internet of Things and have made it big in the home automation systems of today. Now, other than making your home smart, IoT devices are also capable of intelligently tracking your health and fitness. And as far as fitness goes, the Fitbit tracker or the Apple Watch and other such smartwatches have been a revolutionary success. And along with your fitness aspects, they also solve your day-to-day healthcare needs like checking your heart rate and perspiration levels and tracking your body temperature to predict a cold or a flu on the way. And you'll be amazed to know how the other IoT devices are saving more lives and making healthcare better, like the Philip Healthcare's medication dispensing service or the Hero Smart Pills dispenser are the most successful use cases today and exemplify the potential of IoT in the healthcare sector. It is the perfect reminder for your medications and is a convenient measure for the elderly and the sick alike. With the option to remotely manage it with your smartphone, you could also monitor the medication of your near and dear ones and be notified upon running low on any medication at all. Plus, you could also get info on the right medication for common health hazards. And now, with how integral smartphones and internet have become in our lives, health and fitness solutions using IoT will only get more and more prominent in the recent years to come. So apart from the personal benefits that you can get as a consumer or a user, IoT also aims to impact the greater good. The talk of smart cities is prevalent these days, where the waste management system is more efficient, pollution in the environment is checked, and even the outdoor lighting and traffic signals are equipped with motion sensors to ensure energy conservation by turning on only upon detecting traffic updates in its route or upon sensing pedestrians and vehicles nearby. Now let us look at some of the other sectors of service and civic amenities that these IoT devices are powering to up the efficiencies of our world today. One of the most visible smart systems in place is in the domain of transport and automotive today. And along with more and more connected car platforms today, there has also been a lot of hype around smart and self-driving vehicles hitting the lines of transport very soon. Plus, with the maps providing real-time intel and the modern vehicles housing numerous sensors in them, you could always tell which way to go or what parts need to be looked at. Like say tracking the fuel consumption, altitude and maintenance issues of flights in real time without waiting for it to land every time can help in anticipating problems to schedule maintenance prior to its arrival so that delays and mishaps are minimized in the aviation industry. Another major area of application for IoT devices is in the field of agriculture. A sector that is often neglected despite its utmost importance can now be brought up to speed with IoT. With several cheap and minimal sensors that monitor the best climate and soil quality for the right kind of crops, or other smart devices that ensure the efficiency of automated irrigation systems, even the gardens in your home or the trees in smart cities, or even the plant life and vegetation in agroforestry or wildlife habitats could be kept in check. The most innovative IoT devices today include the smart watering system Blossom, which can create optimal watering schedules for all the plants in your home based on real-time weather data and forecasts, and will regulate all your sprinklers accordingly and allows you complete control over them through Bluetooth or the internet. And also the Clean Grow's carbon nanotube probe is one of the best IoT devices for farmers and gardeners all around the world today. With sensors to monitor the intake of nutrients in the crops to better manage farming resources and improve the quality of their fields, farmers can now alter the maturity rate and the color of crops for better yields and faster rates of production. Now, it might be a little ironical of me to talk about one of the very first industries to be made smart on such a late note in today's session, but I really just wanted to save the best for last. And believe me, the sector of retail and logistics is where the Internet of Things promises the most astounding results. With IoT devices already being extensively used in shopping, restaurants, hospitality industries, and many other businesses to control the supply chain effectively and obtain valuable insights based on them and manage their logical or merchandising expenses in the best possible ways. Now, the Q-Hop is one of the leading examples of Internet of Things being used in the retail today. Typically designed to bring in seamless autonomous checkout technologies to all retail verticals by digitizing the checkouts through RFID tags that only unlock after its payment is processed. The sole purpose behind it was to allow users to self-checkout in stores, although it is mainly used for security reasons today to inhibit petty thefts in stores. But guess what? That was before the inception of Amazon Go earlier this year. Now the technology inside this convenience store will really seem like it was pulled out from the future somewhere. Although it is so new that there are only 3 locations with these futuristic stores so far. So operated and managed by the online retailer Amazon, these stores can give you a shopping experience unlike any you've ever had before. With the idea essentially being grab and go, these stores will just need your Amazon Go apps for you to enter and then employs computer vision, machine learning, and sensor fusion to automatically add items that you pick instantly onto your virtual cart and will also remove them off just as promptly if you keep them back. Now, once you've grabbed all the things on your shopping list and are ready to exit, all you need to do is just walk right out of the store. Yes, no more lining up in busy queues of the usually limited checkout counters to wait your turn for the purchase. You can exit the store without even having to pull out any cash or a card, and you will find the amount for all the things that you walk out with debited simultaneously from the balance in your Amazon account. Such a smart system could also check the inventory regularly to notify retailers on the need for restocking and even helps to manage the supply chain in a better way. Now, there are also other promising areas in logistics that IoT devices have started to impact. Like in the case of shipping cargo or fleet management, smart Bluetooth low energy tags are attached to the items being moved for remotely tracking their exact locations, speed of transport, and storage conditions. For instance, the Things.io is a simple IoT platform that provides a dedicated cloud-based dashboard for better logistics by enabling access to real-time and reliable inputs from its connected smart sensors and paired location trackers, irrespective of wherever they might be. So all the use cases and the respective IoT devices or things we just went over are only a select few out of the countless applications of the Internet of Things that can drive almost any sector today. And these IoT devices could be things themselves or even attached to someone or something to make it a thing in IoT. Like even a person with a heart rate monitor could be a thing in IoT as it collects and provides information that can act as inputs to other smart systems to operate on. So the baseline for anything to become an IoT device could be laid out as any object with a unique IP address for communication over networks and the ability to gather and transmit data or receive data and perform tasks based on it. And the embedded technology in these devices are what interact with either the internal states or the external environment to capture all data and drive decisions made upon them. Now, with the Internet of Things being such a large community of different devices, the challenges of IoT devices mainly start with communication, as the protocols and languages used by each of them vary hugely due to the lack of common standards for all of them yet. And this lack of a uniform and secure standard across all IoT devices poses great security risks, making them highly unreliable for most important operations and interoperations today. Also, without customers being assured of the privacy and security of their data, there is just no reason for them to risk using or adopting such insecure solutions. But do you really understand what the role of security in IoT devices is today? Well, let me tell you about a major cyber attack that happened back in October of 2016. A large distributed denial of service attack, dubbed Mirai, affected DNS servers on the east coast of the United States, which disrupted services all across the world. Upon further investigations, this issue was tracked back to the hackers that infiltrated smart networks through the IoT devices being used in them, like the routers or the camera. So that brings about the situation wherein our devices and data are all remotely connected and stored upon these networks, and its security gets compromised. We might even not know it over the first few days or weeks, and it might be just too late by the time we do realize. Now, the way in for these hackers were undoubtedly a result of poor practice at some end, like say the use of default passwords rather than changing them. Hence, the adoption of better practices and the reinforcement of proper authentication, network segmentations, encryption, and cryptography can still make the things and its systems quite secure, given that we start making sure of building them up securely from our end as well. Plus, the issue of overall connectivity is also a feat that our world is still striving to achieve but hasn't been able to accomplish yet. That brings us to the last topic for today. So let me tell you the important things that you should know to build an IoT device. So building an IoT product or device or solution must be done thinking about the relevant purposes that it can serve and the ways in which they can be prepared to work for at least the next couple of decades, along with the option and space for quick improvisations and upgrades. And just like we saw in all our examples today, you must have understood the two important categories that IoT devices are mainly made up of. The first is the hardware aspect, and the underlying rule is to aggregate the hardware in the most minimal way you can without compromising on the primary features that you want your device to use. Now, these features are mostly due to Bluetooth low energy sensors or beacons connected to the internet, or a customized product with probably a combination of these on a circuit board made up of a semiconductor like silicon, and may also house other components like transistors, resistors, receivers, transmitters, actuators, an integrated circuit, or a microchip. So most devices like a smartphone are a result of such combinations on a little more complex level with proper casing and with the second most important aspect of these devices. So the second important category in IoT devices is the software aspect. On the device level, the size of your software will depend on how minimal or bulky your device is and what are the components that you're housing on it. On the most basic note, the device software only needs to be enough for handling the operation of your device, driving components to collect data and converting them into transmissible form, connecting to networks, driving the transmitter to send data and the receiver to receive data to and from the network, and converting it to the machine understandable form for driving components to perform some task or display some outcomes based on the received instructions. Now all this will require very minimal software, unlike the software on your phones that come with entire mobile operating systems. All the other important software for intelligence and smartness in these devices will be provided by the underlying cloud infrastructure and even by the mobile apps or web dashboards. The software aspect of IoT devices is in fact what controls the hardware aspects to sense some information or perform any instruction. While both aspects are the most integral parts of an IoT device, you might also need to overcome a few more hurdles before your IoT device is truly ready to implement smart solutions and power smart systems of our world today. These hurdles could be connectivity issues or compatibility problems or security and privacy concerns. But don't let the obstacles dishearten you. Instead, just consult people with knowledge on the same.
While the Internet of Things equips a multitude of domains and millions of devices with connectivity every day, there are still a few domains which I find a tad more interesting than the others. And they are IoT in everyday lives, IoT in healthcare, in smart cities, agriculture, industrial automation, and finally in disaster management. First, we have Internet of Things in our daily lives. This is probably a hallmark in the IoT industry, as it's also one of the first industries to deploy IoT at its service. So let me give you an example of how IoT can serve us in our daily lives. Consider a home appliance such as your AC. Currently, what you do is that you go home, you turn on your AC, and wait for it to reach a temperature that you like, say about 25 degrees Celsius. So does anybody see a problem here? No one? That's probably because there isn't a problem here. This is a perfectly functional setting. But what if it could be better? What if when your car was 5 minutes away, your AC received a message? What if it was connected to a cloud which had a dashboard containing all the relevant information like the location of your car, the outside temperature, and the temperature at which you liked your room? Your AC could then turn on before you arrived and create an ambience that you like. Wouldn't that be something? Well, you can remove all the what ifs from the previous scenario, as this no longer must just be a figment of your imagination, thanks to the Internet of Things. IoT can connect your Fitbits to your vehicles, from your smartphones to your in-flight services, from home appliances like your ACs to whole entire cities. Maybe this is what Kevin Ashton meant when he spoke of this concept where every area, sensor, man and machine could be connected to one another. So I hope you all are with me till here. So next we have IoT in healthcare. I'm sure most of you have heard about the smart medicine dispensers by now. As the name suggests, it's basically a smart appliance that stores, dispenses, and manages your medicines for you. Now, this is a very small piece of a very big picture. The healthcare and the general practice of medicine majorly faces issues in one or more of these three things. We have your research, devices, and care. Medical research has to rely upon leftover data in controlled settings for medical examination. It lacks real-world data which can solve critical conditions. IoT could be the answer to all these problems. The Internet of Things opens ways to a sea of valuable data through analysis and real-time testing. Internet of Things empowers healthcare professionals and improves the quality of care. Finally, it ultimately reduces the unsustainably high costs of medical devices. So here is an example. This is basically an outline of how a care device works. A care device has certain parameters that are considered safe. Once one of them is breached, the sensor immediately relays this message via a secure gateway to a cloud. Now, it is vital for this gateway to be secure, as it holds all your valuable medical records. The cloud then passes a remote signal to a smart device that is monitored either by a nurse or a caretaker at home. The beauty of remote patient monitoring is that patients can now replace a long wait at the doctor's office with a quick check-in, data share, and instructions on how to proceed. IoT hence bridges the gap between reading devices and delivering healthcare by creating systems rather than just equipment. With that said, let's move on to one of the most talked about prospects of IoT, the smart cities. Now, the thing about a smart city is that a smart city solution is very specific to that one city. The problems faced in Bombay are very different than the problems faced in Delhi. Even global issues such as waste control, traffic management, availability of finite drinking water, housing, and pollution impact different cities with different intensities. So the only way to really make a city smarter is to cater specifically to its problem. One such problem consistent among most urban cities is traffic. So imagine an intelligent device, like a traffic camera. A camera that can monitor the road of traffic jams, accidents, rains, etc., and communicate that status to a gateway. Now, this gateway also receives data from various other cameras from all around the city. This in itself could form a city-wide traffic system. Now, where can we use it? So let's say the municipal corporation has decided to repair a road which connects to a highway for more than one city. Now, this could cause a massive congestion. A smart camera could send this insight to the city-wide traffic system. Now, considering this is a smart traffic system, it quickly learns and predicts patterns in traffic. It will analyze the situation, predict its impact, and relay this information to other cities that connect to the highway via their own monitoring systems. Now, the traffic management systems then can derive routes for cars around these projects. Live instructions could be sent to drivers via radio channels and their respective smart devices. What is a bonus is that if there is a school or an office building which has no other way but to use that road under construction, they can be automatically called and asked to reschedule. This creates a network of self-dependent systems which leverage real-time control. And this is just one example of the potential benefits of IoT applications. So next we have a sector which is most neglected despite the importance it holds, that is agriculture. However, manual handling often results in loss of energy, labor cost, and other inaccuracies, which make all its processes less effective. Internet of Things here can provide with a number of solutions. Precision farming, smart irrigation, and smart greenhouse are a few to name. The first two cases are pretty similar, as in both cases there are sensors detecting various parameters at each level of the soil. We have moisture content, temperature, and weather conditions. One can tell the correct depth to sow the crops or the right time to water them. But one of the more intriguing solutions is the smart greenhouse. A lot of you might be wondering, what is a greenhouse? So the greenhouse is a farming technique where you can increase yield by controlling natural parameters. So if we could use embedded devices in these greenhouses, we could not only just monitor it regularly, but we could practically control the climate inside the greenhouse. So how the system works is that the sensors sense various parameters and areas of issue inside the greenhouse. They then relay the information via a connection gateway to the cloud, which then sends remote commands via the same gateway back to the sensors. So once these signals are acknowledged, they are passed on to the switchgear, which then activate the lighting, pumps, and turbines inside the greenhouse, which then create artificial sunlight and sometimes artificial precipitation inside the greenhouse. What more? From the connection gateway, as you can see, there is a monitor through which 24/7 real-time monitoring has come into effect. Also, you could use any smart device to remote the conditions inside your greenhouse. So with elimination of irregularities and human errors, This creates a much more efficient system. So with that, we conclude the role of Internet of Things in agriculture. So next we have another domain where IoT could prove to be a game changer. This is one of those fields where both faster developments as well as the quality of products are the critical factors for a higher return on investment. I am talking about the industrial automation sector. But there are still a few problems that need to be addressed in this sector. I think you all might have already guessed what I'm going to say. Well, IoT comes to the rescue again. The Internet of Things improves the line of command immensely. It optimizes packaging and makes quality tests so much easier to run. What more, you do not even have to worry about the training cost of too much staff or a lot of staff going on a holiday because these factories pretty much run on their own. You can monitor the supply chain in real time while keeping an eye on your inventories. With IoT applications, one could even re-engineer products and their packaging to deliver better performance in both cost and customer experience. So this brings me to the final application for today. That is disaster management. Now, the IoT cannot stop disasters from happening, but it surely can help in preparedness and resilience during one. Due to high population density, poor evacuation infrastructure, and exposure to severe weather events, developing countries are more exposed to the risks of natural disasters and often have limited means to sustain the effects. As a consequence, according to a study, more than 95% of all deaths caused by a disaster occur in developing countries. IoT can compensate for this by prediction, preparedness, response, and recovery to rescue developing and emerging countries from their vulnerable positions. Let me give you an example of a forest fire where IoT could be used as a solution. To be prepared for critical incidents like a forest fire, sensors are installed near the perimeters of the forest. They contribute to data feeds about temperature and carbon emissions to a control room which is common to the entire town. This is done via a secure network gateway in real time. They anticipate problems and put defenses in place to mitigate their impact, namely the police, the nearby hospitals, and most importantly, the fire brigade. If such an emergency occurs near urban areas, people and communities are alerted via social media, conventional media channels, and SMS. This brings me to the end of all applications that I had listed. Now that we've gone through a few applications of IoT, let's move on to its future scope. In just 1 year, internet connected devices went from 5 million to billions. But there are still a few areas that need work. So the devices forming the base of IoT are wireless in nature and reside at very remote places where energy is a very vital issue. So with growing functionality of each device, we need algorithms and hardware that are energy efficient to avoid quick draining of batteries. We need to make sure that sensors are active for longer durations. Like any other advancement in technology, even in IoT, security is a standout issue. This issue keeps getting bigger with more and more devices being connected to one another. We need information seclusion methods to benefit end clients and secure their data and privacy. Now, it will be really tough to implement the anytime concept of IoT in reality. But this needs continuous work, and the closest we can get to this is only by reducing the complexity of each existing time systems. We need continuous work to reduce the gap between near real time and actual real time. IoT applications promise to bring immense value into our lives. In fact, the number of openings for IoT professionals is at an all-time high. So I think it is the best time to begin exploring the true potential of this technology. From smartphones to smart cars to that Fitbit on your wrist, IoT represents millions of rupees of potential for an industry. As the Internet of Things becomes more important for companies of all sizes, IT professionals are beginning to seek out roles related to this growing niche. So before going into the session, let's quickly look at our agenda. So we'll start off by discussing a little bit about the current scenario in IoT, market trends, current salary situation and projections in IoT, and how it compares to other sectors. After which we shall see the salary trends in IoT by both experience and functional areas. Also, I shall be talking about the companies that are hiring for IoT as well as the roles they offer. Then I shall discuss the skill set you must acquire before applying into the sector. And finally, we'll see an outline of the training provided at EduReka. So without much ado, let's get straight into the module. So with the proliferation of connected devices, IoT has ventured successfully across all working areas in India and abroad. India is quickly becoming one of the largest hubs for IoT across the globe. Companies are viewing IoT as a key enabler in various fields and are open to integrating it into existing infrastructure. As the adoption of IoT has increased, IoT market is also expected to increase quite exponentially. So with that, let's talk a little bit about the salary trends and projections. Now, the median salary of IoT professionals is 15.2 lakhs per annum, which is according to the 2017 study. This figure compared to the 8.65 lakh per annum in the IT sector gives about 76% more to IoT professionals. IoT being a relatively new entrant, professionals in this area are commanding higher salaries. This number is predicted to go up as much as 17.5 lakh by 2019. So let's see how IoT does compared to other contemporaries. Like I said before, IoT pays 76% more than the IT sector. Interestingly, only 33% of IoT professionals have salaries under 6 lakh per annum, as compared to 58% in the IT sector. Also, we can see around 16 to 18% of IoT professionals in India earn in a salary bracket of 10 to 25 lakhs per annum. Almost 5% of IoT professionals occupy the largest salary bracket, that is 50 plus LPA, while in other domains, barely 2% of the workforce commands this figure. With that said, let's look at the salary trends for IoT professionals in India and the US according to the current financial year. So what I've done is I've divided this into two parts, salaries according to functional areas and then according to the experience level. First up, we have salary trends by functional area. Now, as you can see, I've divided this into 4 functional areas which majorly command the IoT industry. One is embedded systems, next system programming, then we have the engineering design, and finally application programming. In one end of the spectrum, we see application programming being the highest paying job in India with an average of 13 lakhs per annum, whereas its US counterpart pays about $69,000 per annum. On the other side of the spectrum, we have embedded technologies, which pays an average of 8.2 lakh per annum in India, but in US it is the highest paid in the sector with an average of $89,000 per annum. The system programming and engineering design sectors lie somewhere in between with 11.6 lakh per annum and 10 lakh per annum respectively. As for the experience level, more than 90% of freshers in the IoT field fall under the 6 lakh per annum salary bracket, which is not a bad number for a fresher. On the other end, somebody who has a decade of work-ex in this field can quote up to a 30 plus LPA salary. Now, what is interesting here is that from each experience level bracket to a higher one can lead to almost 50% jump in the salary. With this, I think we've covered the salary aspect of this industry. Let's move on to the career aspect of IoT. I'm sure a lot of you must be waiting for me to disclose the names of companies and the roles they offer. So the concept of IoT has given rise to a new era of economic growth, and companies are looking at it to transform their businesses. Now here you can see 2 types of companies. Firstly, there are companies like Dell and IBM, which have a vested interest. Their core products and services are built around delivering and facilitating IoT. But there are also companies like Verizon and Accenture where it is more about preparing for the future. Although IoT hasn't completely changed the face of IT,
it has definitely created new opportunities for job seekers in the markets. I shall be elaborating on this in the following sections of the module, which brings me to current roles for IoT professionals. Now, if you were to ask me what field do you need to be in to land a job in IoT, the answer would be many. IoT works on many layers. Software plays a key role in usability and functionality. Network layers are key to infrastructure, and hardware defines capabilities and development opportunities involved in an IoT solution. Existing professionals with transferable skills will definitely find progression opportunities with IoT. The IoT is based off many technologies that IT professionals are already familiar with. IP experts, both software and hardware engineers, and even UI designers could find themselves to fit in somewhere in the industry. These companies could be ranging from startups to tech giants that are driving the industry. But with various domains that have adopted the potential usage of industrial IoT, it has led to a massive job creation. But unlike the other fields, IoT job market is a complex one, given the wide variety of skill sets required in this place. Here are some emerging job profiles for IoT professionals a few years down the line. First up, we have solution architects. Now, what a solution architect does is that it takes an idea and converts it into a design, and then takes the design and converts it into code. Now, a solution architect may not be a back-end developer, but it takes the requirements of the company and then turns it into solution blueprints, which brings me to another very important player in this end-to-end execution, which is the product manager. The responsibility of a product manager may be many, but mostly it revolves around making sure that the clients get the solution they asked for on time. Moving on. Now, when we talk about IoT, we talk about huge amounts of data. And where there is huge amounts of data, we have analytics on top of it. So this is a job profile created specifically for the IoT industrial field, which is the industrial data scientist. These are data scientists that basically work with sensor data and have expertise on it. Which brings me to another very important industrial job profile, which is the industrial engineers. Now, as I've mentioned before, hardware plays a key role in the development of connected devices. For that, we need material specialists who can work on semiconductors that are used to make microcontrollers and microprocessors in those connected devices. Next up, we have another role that is created specifically for the IoT field. Now, IoT has pushed the developers to go beyond a full stack. We need developers at the back end who are not only proficient in software coding, but also in hardware programming. Hence, we have the fuller stack developer, which brings me to our final emerging role in IoT. As we have all known and predicted, very soon our shop floors are going to be taken over by robots. So what do we need? We need a supervisor who can take care just in case there is a miscalculation or a breakdown. This has created the final job profile that I'm talking about today, the robot coordinator. With that said, let's move on to our next topic. So while IoT is poised to be the next great boom in the field of jobs, lack of skill is citing the biggest barrier for companies that are looking to implement this technology. To be considered for any of the roles mentioned earlier, the qualifications you need are no different than an IT development role. Proficiency in coding and fundamental in object design are at least required for your resume to be looked at. But the skills you need here are way more than that. Businesses who engage in IoT technologies are businesses that are invested in the future. They are seeking forward-thinking professionals who not only meet standards in academics, but also have soft skills and innovative thinking. I am talking about people who can integrate deep knowledge in embedded technologies and concepts of cloud computing and edge computing. These people are tipped most to be in demand. Next up, we have networking and communication protocol. These are very important as devices need to be connected to one another at all times in real time. Finally, we need professionals who can convey a complex idea in simple ways, either speech, written communication, or other abstract methods. So the IoT job market is the perfect platform for job seekers to showcase their skills and for companies to establish relationships with these professionals. So this is the best time to get into this technology. And who better to guide you than the IoT trainers at Edureka? So Edureka provides an IoT certification training, and the outline of its syllabus looks something like this. This training course is tailored specifically by industry experts, and it takes you through concepts such as IoT framework, ecosystem, and solution architecture. It also teaches you networking protocols and application layer in depth. You shall be working with Raspberry Pi and Sense Hats and will gain hands-on experience with Azure IoT Hub and Alexa Voice. This course also has a real-life demo and case studies which will help you master the IoT technology. So concluding, I would like to say that IoT is amidst an explosion. This definitely suggests optimistic future for professionals looking to dive into this industry. So grab this opportunity while you still have it. Thank you and have a great day ahead.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!